Microservices is a modern approach to build software applications, where an application is composed of collection of small and autonomous services. Microservices are loosely coupled, meaning that they can be developed, deployed, and scaled independently of one another. Hi everyone, welcome to this Microservices Full Course. But before we get started, if you like our videos, then please do not forget to subscribe to Edureka YouTube channel and hit the bell icon to stay updated with all the latest trending technologies. Also, if you are interested in our Microservices certification training, then please click on the link given in the description box below. Now let us get started with our agenda for today. In this session, we will be discussing the microservices fundamentals, including what microservices are and how they differ from traditional monolithic. We will also cover the microservices tools as well as the design patterns of microservices. After that, we will cover the microservices Spring Boot, followed by the microservices security. We will also look into the difference between microservices and SOA. And the next difference is Microservices Vs API. We will wind up this session with some of the most important microservices interview questions. By the end of this session, you will have a solid understanding of what microservices are and how they can be used to build scalable and resilient systems. So, let us dive in and learn more about the exciting and rapidly growing field. Now, without any delay, let us get started with our first topic, that is, what are microservices?
Why we need microservices. So before microservices, we all know that there was an architectural pattern called monolithic architecture that was used. All right. So there are certain disadvantages of that architecture, but let me first explain you that architecture, what exactly monolithic architecture means. So basically in this, the entire software is composed in a single piece that is designed to be self-contained. So what I mean by that, basically all the components of a monolithic program are interconnected and interdependent. Or in other words, if I have to put it, I'll say that it will give you a tightly coupled software where each component along with its associated components must be present in order to execute or compile the code. So all of these components are actually dependent on each other. So if you notice the definition that is there in front of your screen, it says that monolithic architecture is like a big container, right? Think of it as a big container wherein all the software components of an application are assembled together and tightly packaged, right? So if you notice that there is an example in front of your screen, so there's a server-side application, right, which executes a domain-specific logic. It will retrieve and update data from the database and at the same time populate the HTML views to be sent to the browser. So it is basically a big container, or I can say that it is not divided into small services or not divided into small components. So even these components that are there are pretty tightly coupled, right? So I'll give you a better example of what exactly monolithic architecture is. Let me just move forward. So let us discuss a classic example of an e-commerce website like Amazon or Flipkart. All right. So everyone actually visits these websites quite often. So that's a perfect example to explain you. So let's understand what monolithic architecture exactly means with this example. So as you see that in basic e-commerce application, we have a common option of customer service, right? Product service and cart service, which a customer can access through their browser, right? And when you launch the application, it is deployed as a single monolithic application. There's only one single instance, if you can notice. So we have customer service, product service, and cart service. And when you deploy all these services, it will be basically a single monolithic application. Now, what you can do is in order to scale it, you can run multiple instances of this application behind a load balancer, right? Now, let me discuss few advantages of this application. So first of all, it is very simple to develop, right? As a goal of the development tools and IDs is to support the development of monolithic application, it makes the development really easy and one directional, all right? Now, it's pretty simple to deploy because you have to deploy the executable file at the runtime to launch the application. That executable file can be a WAR file as well. Now it is pretty simple to scale as well because in order to scale your application, all you have to do is run multiple copies of the application behind a load balancer. Now, since everything comes with its pros and cons, monolithic architecture also has few major drawbacks. Let's discuss about them one by one. The first disadvantage is large and complex applications. Now, if you have a large application, or you can say with the increase in size of the application, it becomes really complex to understand and modify such applications, right? And as a result, development slows down and modularity breaks down over time. Moreover, because it can be difficult to understand how to correctly implement a change. And due to that, the quality of code declines over time. Let's see what is the next disadvantage. So the next disadvantage is slow development. So what I mean by that, as the application and the respective teams grow, the application becomes difficult to understand and modify, right? Because it's pretty huge in size and there are multiple teams working on it. So it becomes really difficult to understand and modify. Also, the larger the code base leads to slower ID, which makes the developers less productive. So the code base is pretty large because the entire application is one monolithic application, right? There are not different services present. Now it blocks continuous development. So what I mean by that, a large monolithic application is an obstacle to frequent deployments. Let me tell you how. In order to update one component, you have to redeploy the entire application, which interrupts the background task. So if I have to take the example of the e-commerce website, if I have to update the cart service, I have to redeploy the entire application, which includes the customer service, the product service, all the services, right? So there is also a chance that components that haven't been updated will fail to start correctly, all right, because of many dependency issues or anything, right? And as a result, the risk associated with redeployment increases, which discourages frequent updates. I hope you're getting my point. Let's see what we have next. So the next point is unscalable. I know I've told you that it's pretty easy to scale, but let me tell you what are the disadvantages when it comes to scalability and in terms of monolithic architecture. So each copy of application instance will get access to all of the data, right? Which makes caching less effective and increase memory consumption along with input output traffic. Also, different application components have different resource requirements. One might be CPU intensive, right? While other might be memory intensive. And with a monolithic architecture, we cannot scale each component independently, right? So if you can see the example that is there in front of your screen. So here we have customer service, product service, and card service. This is one instance, and this is how we are scaling it, right? If I have to increase only the customer service, I have to scale up the customer service. I have to do that for product and card service as well, right? Now it is pretty unreliable as well. Let me tell you how. So because of the tightly coupled components, if one of them goes down, the entire system will fail to run. What I mean by that, if one of my, say, product service fails, that will in turn lead to the downfall of my entire application, right? And because all the modules are running within the same process, a bug in any module can potentially bring down the entire process. Moreover, since all the instances of the application are identical, the bug will impact the availability of the entire application. This makes the monolithic architecture highly unstable and unreliable. The last and the final point is inflexible. So how is it inflexible, guys? With the monolithic architecture, it becomes really difficult to adopt new frameworks and languages. Suppose you have million lines of codes written with XYZ framework. Now, it would be extremely expensive in terms of time as well as cost to rewrite the entire application to use the newer ABC framework, right? Even if that framework was considerably better. And as a result, there is a huge barrier to adopting new technologies. I hope you're getting my point. So why is it very expensive? Because you have written million lines of code in some language. Now you want to use some other language, right? So it becomes really expensive and a time consuming task. And even if the new language or the framework is considerably better, but there's a huge barrier in adopting such new technology. So I hope you have understood the various disadvantages of monolithic architecture. Now is the time to understand what exactly is microservice architecture. Microservices, also known as microservice architecture, is an architectural style that structures an application as a collection of small autonomous services modeled around a business domain. Now, if I have to put it in simpler terms, basically, it is a self-contained process which avails different and unique business capabilities. Now, if you have large applications built using this architectural pattern, it can be broken down to small multiple services which together acts as one large system. But behind the scene, it's a microservice. So what I'm trying to say here is we have multiple services. On all of these services, they don't share the data structure, but they'll be communicating through APIs, right? The major advantage of breaking down the system is now each microservice can focus on only one single business capability, which definitely leads to a better quality and throughput. And it's obviously becomes easy for you to understand when I explain you with a example. Again, I'm going to take the e-commerce site example. Now, if you remember in monolithic architecture, all the components were in a single module. But if you see here with microservice architecture, all the components are divided into separate modules, which communicate with each other using a well-defined interface, usually REST or messaging. Now, the communication between the microservices is a stateless communication where each pair of request and response is an independent transaction. And because of this, microservices can communicate effortlessly. Moreover, in microservice architecture, the data is federated. All right, so let me just break it down for you. Each microservice is responsible for its own data model and data, because of which interaction with each microservice is handled by different instance. Unlike in monolithic architecture, where we had only one instance, here we have multiple instances for different microservices. So we have three microservices here: customer microservice, product microservice, and cart microservice. Right? Each of them have their own instances, they have their own data model, and they have their own data. So this is what exactly microservice architecture is. Now let's dig a bit deep into its architecture and understand what it is. Now, as you can see, in a microservice architecture, services are small, independent, and loosely coupled. So let me just tell you where it is. So these are multiple services, right? So these are pretty small in size, and they're independent and loosely coupled. Now, each of these services have a separate code base, which can be managed by a small development team, and it is deployed independently, right? So this service will have a code base, this service will have a code base, this service will have a code base. Similarly, all of them will have a code base, which will be not huge in size when you compare it with the monolithic architecture where all of these services are running in one instance. I hope you're getting my point. Now, basically, a team can update an existing service without rebuilding and deploying the entire application. For example, if I have to update this particular service, I don't have to do it for the other services as well. I can just redeploy the service independently. Now, services are responsible for persisting their own data or external state. Internal implementation details of each services are hidden from other services. Moreover, they don't need to share the same technology stack, libraries, or frameworks as well. Right? You're getting my point. So they might not have the same technology or same libraries or the same framework, and they have their own database and things like that. So they are pretty independent from each other. Besides, for the microservices themselves, some other components appear in typical microservice architecture. So let me just discuss that. So the first part is management. So the management component is responsible for placing services on nodes, identifying failures, rebalancing services across nodes, and so forth, right? Then let's talk about service discovery. Now, service discovery, the task of this component is to basically maintain a list of services and which nodes they are located on. It enables service lookup to find the endpoint for a service. Let's talk about API gateway now, right? So API gateway is basically the entry point for clients. So this client won't call all these services directly, right? It will first go to this API gateway, which will forward the call to the appropriate services on the backend, right? If I'm a client, I'll request for this particular service, then I have to call the API gateway, and which will in turn call the service on the backend. Now, the API gateway might aggregate the responses from several services and return the aggregated response. Now, it might be possible, right? A client request from multiple services. So at that time, it will aggregate the results from various services and will return the aggregated response, right? So I hope I am clear with the architecture. Let us focus on what are the features of microservices architecture. The first feature is small focused. So what it means that the aim of microservice architecture is simplicity, you know, so that it can be rewritten and maintained without any extra efforts by the development team, right? That's what I mean by small focused. Then the next point is loosely coupled. So as I've already mentioned multiple times that each microservice is independent of each other and do not need to coordinate as well. This makes the development as well as the deployment real quick, guys, right? So if I have to update a particular service, I'll only update that service. I won't, update the other services, right? So that way deployment becomes really quick. So that's the big advantage. Now let's talk about language neutral. So to be a good microservice, it must be language neutral. So what I mean by that, for example, in an application, few services can be written in Python for fast deployment, whereas few might be written in Java because it's speed and extensive libraries, right? So depends on the microservice, what kind of programming language we are using. So it doesn't really affect the other services, right? Now, bounded context. So it means that each microservice doesn't need to understand the implementation of other microservice. So these are a few features of microservice architecture. Now let's talk about various advantages of microservice architecture. Now, the firstly, independent development. So each microservices can be developed independently, where a single development team can build, test, and deploy a service. I think I don't need to explain this much. Independent development means if I have a product service, then I can independently focus on product service, where a team of developers are writing code for that particular service, testing it, and deploying it. Now, independent deployment means that you can update a service without having to redeploy the entire application. Bug fixes and feature releases are more manageable and less risky as well, because you have to focus on one particular service. You have to deploy or update one particular service. You don't have to care about the other services or the entire application as such, right? So next is fault isolation. So it is a very big advantage, guys. Basically, if a service goes down, it won't take the entire application down with it. For example, if my card service goes down, my entire application is largely unaffected. Unlike the monolithic architecture, where if one of my component goes down, the entire application fails to work. Next is mixed technology stack. Because of this feature, teams can pick any technology which fits best for their service, right? And last but not the least, granular scaling, which means that services can be scaled independently. Unlike my monolithic architecture, where I have to deploy multiple instances. So in order to scale, here I can only scale a particular service. If I have to, increase the card service, then I can just scale up the card services instead of scaling up the entire application. So let's move forward. So there are a lot of companies which are using microservices. We have Amazon, Netflix, SoundCloud, Twitter, Uber, PayPal, a lot of companies, right? And why this happens? Because large applications become easier to manage when they're broken down into smaller composable pieces. So without any further delay, let's begin with our hands-on. We'll be using Spring Boot because it provides a way to provide Java applications quickly and simply through an embedded server. And by default, it is version of Tomcat. It will basically eliminate the need of Java EE containers. And with Spring Boot, we can expose components such as REST services independently, exactly as proposed in the microservice architecture that we have just discussed. In any maintenance of the components, we no longer make the redeploy of its consumers. I'll tell you what exactly I mean. What is a consumer? For this lab, we'll use Eclipse, Oxygen, and Maven 3. Now, to illustrate the concept of microservice, what we'll do, we'll create 3 Maven projects in this hands-on, and each of them will symbolize backend functionality, or you can say reusable APIs. And one of them held a composition. If I have to put it in simpler way, I will say it will be a consumer of the other two. So one application or one service will be a consumer of the other two services, right? So we'll be creating 3 simple Maven projects that I've already done. I'll just open my Eclipse and show you that. So my first Maven project is basically diagnosis microservice. Then we have doctor microservice and we have patient microservice. So this doctor microservice is the consumer, right? And consumer of the other 2 microservices, that is patient and a diagnosis. All right. So that is how it is done. Now, if I have to explain one of these services, let me explain you the patient microservice first. So over here, as you can notice that we have a pom.xml file. So basically this pom.xml file will establish all the dependencies, right, before we start coding. The first class that we create that we call application will be identical in all 3 projects. And it only works as an initiator to Spring Boot that we call as Spring Boot application annotation. So that's how it is. If you notice here, we have application.java. So it will be common. Application.java and application configuration.java are the 2 packages that we have created, will be common for all the other microservices as well. So if I show you for doctors as well, so here also we have application.java and application config.java. Similarly, for diagnosis as well, if you notice, we have both application.java and the other things as well. Now we have patient.java and we have patient rest.java, right? So the patient.java, here we have defined all the variables like, the email ID of the patient, name and things like that. And this patient rest.java will be used to provide the input to the variables. I hope you're getting my point. The patient rest.java is basically to provide the input. I won't be explaining the code here. In the upcoming tutorials, I'll be explaining the entire microservice, how the code works and everything, all the technical details you can find in the next tutorial. In this, I'm just giving you an overview of how things work in microservices. And we have this application config class as well, right? The package. So let me tell you why we actually use it. It's basically, it is a resource configuration class, which is basically a resource manager responsible for exposing REST services for application consumers, right? So basically for messaging, right? So the REST service is for messaging and it is a stateless service for application consumers. And we can notice that patient.java and patient rest.java are in the same package, right? Now let me tell you how I've defined the ports here. So all I have to do is right click, go to properties, click on run debug settings. And when I go to arguments, right, so I just have to write -d server.port 8081. So you can see that my patient microservice will be running at a port 8081 when I start it. Let me just start all of these services one by one. So I'll start this first. Just click on run as Spring Boot app. Similarly, right click on this and I'll just run it as Spring Boot app again. And I'll run this also as a Spring Boot app. So it's done now. Let me just open my browser. All right, so this is for port 8081, right? So my port 8081 is for patient. So let me just click over there. Let me reload this page again. So here I have my patient microservice. Similarly, my port 8082 is for diagnosis, right? So here I have the diagnosis microservice. And finally, my port 8083 basically is a consumer. All right, it's a doctor microservice. And in the URL, if you notice, I have written patient ID, right? Diagnosis and consultation, right? So basically, we'll get, this particular patient has been diagnosed with this disease, and this is the consultation, right? So let me just reload this again for you. So I can just go ahead and change the diagnosis as well. I can make this as 2, right? So Rachel has been diagnosed with a different disease now. Similarly, if I make it as 1, she has been diagnosed with viral fever here, right? So that is what the difference is. Basically, this particular microservice is a consumer of the other two services, right? So you can even think of it as an e-commerce application. I know it's not of that level, but consider it something like, customers, products, and orders. So this patient microservice will become the order microservice, right? And the other two will become customer and products. So this order microservice will be a consumer of the product and customers. Similarly, in this example, we have patient and doctors. We have patient microservice and we have diagnosis microservice, and we also have a doctor microservice, which is actually a consumer of the other two service.
Why do companies migrate from monolithic to microservices? In this case, we shall take an example to help you understand better. Netflix is one of the earlier, most well-known adopters. Some other well-known examples are eBay, Amazon, Twitter, Alation, etc. In 2009, Netflix faced growing pains. Its infrastructure couldn't keep up with the demand for its rapidly growing video streaming services. The company decided to migrate its IT infrastructure from its private data center to a public cloud and replace its monolithic architecture with a microservices architecture. The only problem was the term microservices didn't exist and the structure wasn't well known. Netflix became one of the first high-profile companies to successfully migrate from a monolith to a cloud-based microservices architecture. It won the 2015 Jack Special Jury Award due to this infrastructure that internalized DevOps. Today, Netflix has more than 10,000 microservices that manage and support separate parts of the platform, while its engineers deploy code frequently, sometimes thousands of times each day. And another example we have is Atlassian Corporation plc or Public Company Limited. It's an Australian software company founded in 2002, and its headquarters is in Sydney, Australia. They develop products for software developers, project managers, and other software development teams. Atlassian followed the path to microservices in 2018 after they faced growing and scaling challenges with Jira and Confluence. They found that their single-tenant monolithic architecture running on-premises will not be able to scale for future needs. Now they decided to re-architect Jira and Confluence and move them from a stateful single-tenant monolithic system to multi-tenant stateless cloud application hosted by Amazon Web Services. They will decompose them over time into microservices. The project was named Vertigo. It was their largest infrastructure project till date, taking 2 years to complete the transition to AWS, migrating more than 100,000 customers in just over 10 months with no service interruption. They also committed to decomposing the services to microservices. Now let's come to our topic for today, that is monolithic versus microservices. So as the first point of comparison, we have the definition. A monolithic architecture is a traditional model of software programs which is built as a unified unit that is self-contained and independent from other applications, whereas a microservices architecture, also simply known as microservices, is an architectural method that relies on a series of independent deployable services. Secondly, we have deployment. In monolith architecture, one executable file or directory makes deployment easier, whereas in microservices architecture, they have independent deployable. Since microservices are individual units, they allow for fast and easy independent deployment of individual features. Thirdly, we have scalability. In monolithic architecture, you can scale individual components, whereas in microservices, due to flexible scaling, if a microservices reaches load capacity, new instances of that services can rapidly be deployed to that accompanying cluster to help relieve pressure. Fourth, we have reliability. In monolithic architecture, if there's an error in any module, it could affect the entire application's availability. Whereas on the other hand, with microservices architecture, you can deploy changes from a specific service without the threat of bringing down the entire application. The fifth comparison we have is development. In monolithic architecture, when an application is built with one code base, it is easier to develop, whereas microservices add more complexity compared to a monolith architecture, since there are more services in more places created by multiple teams. The sixth comparison we have is flexibility. In monolithic architecture, due to lack of flexibility, a monolith constrained by the technologies already used in the monolith, whereas microservices architecture, on the other hand, is flexible. So microservices architecture allow teams the freedom to select the tools they desire. And the last comparison we have is debugging. In monolithic architecture, debugging is easier. With all codes located in one place, it's easier to follow a request and find an issue. On the other hand, each microservices has its own set of logs, which make debugging more complicated.
Now, if you ask me what are microservices, my answer would be really simple. Microservices tools are basically a collection of various tools and technologies having different functionalities. These tools are used in various stages of building an application and help the developer to work with ease. Alright, so they come with basically predefined functions, algorithms, and a very user-friendly GUI to make sure that developers can build their applications in an easy manner. Not only this, but startups to multinational companies have been using microservices in their day-to-day business activities today. And to make sure that they can build the application in an easy way, many other companies are building up new tools and technologies, right? So while building an application using microservices, I would not say that only a single tool is enough. Maybe I would say a couple of tools together will help you build the application in a more easy way. So on that note, let's look into the different tools that we can use for different purposes. So starting with the first one, that is operating system. Now, one of the most important factors of building an application is setting a proper foundation of your application. So this is basically done by the operating system. Now, Linux is one such operating system which is most commonly used in today's market to build applications. With the help of Linux containers, it provides a self-contained execution environment and lets you orchestrate small to big services like security, networking, and storage. So if you ask me what are the better choices of Linux family, then I would say Red Hat and Ubuntu are the go-to solutions for anybody in today's market, but they come with a lot of unnecessary functionalities which are not needed for microservices. Apart from these, Linux providers have also come up with tools such as Atomic Red Hat and Ubuntu, including LXD, which is basically a container-oriented hypervisor. So I would say that you can go for any operating system that your company chooses to build an application or maybe you're comfortable with. But Linux is one such operating system which is growing in today's market and helps the developers to build the applications easily. Now, let's move forward with the next one, that is programming languages. Now, the main advantage of microservices is that different languages and technologies can be used to build different services of the same application. So what I mean by that is, let's say you have 5 services in the same application. Now, the first service can be built using Python. The second one can be built using Java, the third one can be built using Go programming language, and so on. So it basically gives the developers the freedom to choose the technology stack and build the application. But the most popular programming languages used in microservices are Spring Boot and Elixir. So talking about Spring Boot first, Spring Boot basically simplifies the creation of REST-based microservices with the help of Spring Boot frameworks in just a few lines of code. Right? So if you ask me the features of Spring Boot, then it provides auto configuration to load a set of default configurations for quick start of the applications. It comes with embedded Tomcat, servlet containers, and Jetty to avoid the usage of WAR files. Spring Boot also has an opinion to reduce the developer effort and simplifies the Maven configuration. And finally, it consists of a wide range of APIs for monitoring and managing applications in the development side and also on the production side. So Spring Boot is one such programming language, guys, which is very famous in the field of microservices. And you would always see that, developers are trying to build microservices using this particular framework. All right, so that was about Spring Boot. Next, let's move forward with the next programming language, that is Elixir. Now, Elixir is a general purpose programming language which runs on the Erlang virtual machine. Now, Elixir shares the same abstractions for building fault-tolerant and distributed applications. So if you want me to mention a few features of Elixir, then I would say developers can easily write the code in short, fast, and maintainable manner. This code basically runs in isolated lightweight processes which can be scaled individually. For example, let's say you have 5 processes, right? and you don't want to scale a particular process, but you want to scale up the other processes, well, you can definitely do that. Apart from this, Alexia also makes sure that the application never goes down by providing the supervisors. So basically, these supervisors describe how different parts of the system can be restarted if something goes wrong. And that is the main objective of microservices, right? So our main objective is basically that, even if a particular service has gone down, that doesn't mean that, the application will go down. Instead, the bug in that particular service has to be resolved, and then the service has to be restarted. And finally, coming to the last feature, that this programming language comes with its own build tools to create projects, manage tasks, and run the required tests. So guys, these were the two programming languages which are very popular in the field of microservices. Next in this session, let's look into the different tools used for API management and testing. Now, while you start building applications using microservices, you also have to make sure that all the individual services communicate with each other using APIs. So each microservice can have its own API to communicate with the other service. So this is where basically the API management and testing comes into the picture, where all the APIs are present in the system and must be properly managed and tested to get the desired results. So if you want to know more about microservices and APIs and how APIs and microservices collaborate with each other, you can refer to my session on Microservices versus API. Now, the top tools used in API management and testing are basically the Postman and the API Fortress. So starting with Postman. So Postman is basically an API development suite which allows you to easily run UI-driven API tests. With the help of Postman, the exploration of RESTful API resources becomes very easy. So what I mean by that is that, with the help of Postman, you can basically pass HTTP requests to test, develop, and get the required results. Now, few features of Postman are as you can see on my screen. Postman basically integrates with your software development lifecycle in ease. It provides features to design APIs and maintain multiple versions of API with support. This tool can work for small applications to big application, and it also supports collaboration of work by allowing you to save related API endpoints into a collection. Now, once that is done, what you can do is you can go forward and share the entire collection to the other developers. So guys, these are the few features of Postman. Next, let's move forward with the next tool, that is API Fortress. Now, API Fortress is both an API test and health tool which automates the process of load testing, health monitoring, and functional testing. This tool is basically a code-free and is built around modern API architectural patterns and practices. So if I have to mention a few features of API Fortress for you, then this tool is highly interoperable with any platform that you choose in your toolchain and validates APIs built in API management platforms. It also simplifies API test creation and execution by providing a drag and drop GUI. This tool also aims to simplify the end-to-end testing by providing easy generation of functional tests, and also focuses to simplify the collaboration by storing the tests and reports in a collaborative environment to make sure that teams can validate their own APIs if it satisfies the business case. So guys, these were the few features of API Fortress. Now, once you know the tools for API management and testing, the next thing that comes into a microservice system is basically how these services communicate with each other. Well, these services communicate with each other using the messaging system. So the different tools available for messaging are Apache Kafka and RabbitMQ. So talking about Apache Kafka first. This tool is a distributed publish-subscribe messaging system originally developed at LinkedIn and later on became a part of the Apache project. Kafka is scalable and agile and is distributed by design. So Apache Kafka is a distributed stream processing platform which can be used for data processing or API calls. So few features of Apache Kafka are as you can see on my screen. Kafka has high throughput for publishing and subscribing messages to maintain stable performance. This tool guarantees zero downtime and zero data loss. In Apache Kafka, messages persist on the disk as fast as possible, and many applications can plug in and make use of this tool as it offers new write connectors. So guys, these are the various features of Kafka. Let's move forward with the next tool, that is RabbitMQ. Now, this tool utilizes patterns to communicate between microservices and also scale applications simultaneously. With the help of these tools, you can basically connect microservices with each other to solve problems of various distributed systems. Not only this, but you can also use this tool to exchange events between individual microservices. Now, the features of RabbitMQ are as you can see on my screen. This tool basically offers a variety of features such as reliability, delivery acknowledgements, including persistence, publisher confirms, and higher availability. By using this tool, messages are routed through exchanges before arriving at the queues. RabbitMQ comes with the federation model and allows the servers that need to be more loosely and unreliably connected, and also supports messaging over multiple messaging protocols. So guys, these were few features of RabbitMQ. Now, once you're done with your API management and messaging, the next thing is basically that comes onto everybody's mind is toolkits. What do you understand by toolkits? Well, toolkits in layman terms is a set of tools used for a specific purpose. So in microservice architecture also, you can build various kinds of application using different toolkits that are available in the market. So the most popular toolkits available in the market are Fabric 8 and Seneca. So talking about Fabric 8 first. So Fabric 8 is a platform as service tool which helps the developers provide configuration management system through Git. It is an open source tool which handles port mapping and IP addresses complexity. So this tool basically holds the responsibility to load balance services with high availability and scalability. Now the features of this tool are as you can see on my screen. It provides a set of wizards to create application faster and set up continuous delivery pipelines. Fabric 8 also comes with on-premise Git repository hosting. This tool provides Maven Repository Manager, promoted releases, along with a mirror of central Maven repositories, and provides the developer console to create, build, manage microservices with deep visualization into the projects, applications, and environments. Now talking about Seneca first. Seneca is used for building message-based microservices processes and is the toolkit for Node.js. So this toolkit helps you to write clean and organized code with systematic business logic of the application. So a few features of Seneca are as you can see on my screen. Seneca provides plugins which look after the foundation of the application. You do not have to worry about which database has to be used and how to structure your components with Seneca. In Seneca, everything is written as a command, and these commands get called whenever they match a set of properties, and the code that you call does not know which command is calling it. So guys, this was all about Seneca. Now, since you've understood about toolkits also, the next thing that I would like to talk about is the different architectural frameworks. So architectural framework is an important factor while building applications using microservices, and the top two architectural frameworks used are Goa and Kong. Talking about Goa first. So basically, Goa is an architectural framework which provides a way to build REST APIs and microservices using Golang. With the help of this architectural framework, you can design APIs along with its required dependencies, and this framework runs on top of the Google Cloud platform. Few features of Goa are as you can see on my screen. This tool also lets you generate data structures, validation of code, and handlers once the design of API is set. It has a decoupled engine and provides plugins which can implement custom DSLLs and also generate arbitrary outputs. So that was about Goa, guys. Moving on to Kong. Kong is used for ready-to-deploy plugins for enhancing the development and deployment of microservices. With the help of this tool, you can leverage the container and microservices design patterns to quickly build API-centric applications. Now, I've used this term microservices design patterns, right? So if you have to understand this term, it's basically a pattern, or you can say a software pattern through which a company follows based on which the application is built. So if you want to know more about microservices design pattern, you can refer to my session on microservices design pattern. But until then, moving back to this particular session, if you ask me the features of Kong, then Kong provides plugins to extend and connect services across hybrid and multi-cloud environments. It analyzes real-time data and leverages ecosystems to deploy Kong with Kubernetes. Kong connects with automation tools to improve efficiency and reduce errors, and provides role-based access control and encrypts end-to-end to comply with the industry regulations. So guys, that was about the different architectural frameworks present in the world of microservices. Now, once you build an application using microservices, the next thing that comes into our mind is to how to scale the application. Well, to scale this application, you have to use an orchestration system, as microservices work with respect to containers, and so container orchestration becomes an important aspect that has to be considered. So in today's market, there are various tools regarding the container orchestration for microservices, but the top tools available in today's market are Kubernetes and Istio. So talking about Kubernetes first, Kubernetes is an open source container management, or you can understand as an orchestration tool. This tool basically owns the responsibilities of container deployment, scaling and descaling of containers, and container load balancing. So if you ask me a few features of Kubernetes, then I would say Kubernetes can help you to deploy and update secrets and application configuration without rebuilding your image and without exposing secrets in your stack configuration. In addition to managing services, Kubernetes can also manage your batch and CI workloads, thus replacing containers that fail if desired. Not only this, but Kubernetes only needs one command to scale up the containers or to scale them down whenever you're using CLI. Else, scaling can also be done by using the Kubernetes dashboard, right? So if you want to know about dashboard also, you can refer to my session on Kubernetes dashboard. And finally, coming to the last feature, that is with Kubernetes, you can mount the storage system of your choice. What I mean by that is that you can either opt for a local storage or choose a public cloud provider like GCP or AWS, or perhaps use a shared network storage system like NFS or ISCSI. So that was about Kubernetes, guys. Let's move forward with the next tool, that is Istio. Now this tool supports service deployment on Kubernetes. So it basically provides features for manageability, security, and reliability to microservices communication. Now if you ask me how is it done, well, the answer is quite simple. It is basically done by the service mesh technology, which allows you to improve the relationships and interactions between applications and microservices. So few features of Istio are, as you can see on my screen. It performs automatic tracing, monitoring, and logging of the services. This tool automatically secures services through managed authorization, authentication, and encryption of communication between services. It also controls the flow of traffic and API calls between services, conducts a range of tests and upgrades with red or black deployments, and finally also applies policies and ensures that they're enforced and resources are fairly distributed among the consumers. So that was about Istio, guys. Now once API management is done, messaging system is done, and then you have your tools for orchestration also, the next thing is to monitor your application. So to monitor your application, the top tools that can be used is Prometheus and Logstash. So talk about Prometheus first. Prometheus is a monitoring tool which basically allows visualizing monitoring information and supports time-based tracking for anomalous patterns which have to be detected. Also, this is an open source tool which basically gathers monitoring information. So the features for Prometheus are, as you can see on my screen. It provides a flexible query language. It comes with distributed storage and single server nodes which are autonomous. It discovers targets via service discovery or static configuration and provides dashboarding and graphing support. Now talking about the next monitoring tool, that is Logstash. Logstash is also an open source tool through which you can check the logs. This tool basically lets you stash, centralize, and transform data. So the features of Logstash are, as you can see on my screen. It supports a variety of inputs which pull in events from a multitude of common sources all at the same time. This tool aims to transform and prepare data regardless of its complexity. It also allows you to choose your own stash and transport data. And finally, it is a pluggable framework consisting over 200 plugins to create and configure pipeline as you want. So that was about Logstash, guys. Now finally, moving on to the last part of today's session, that is serverless tools. Now these tools are a part of microservices which optimize the methodology of breaking stuff into small functions. So few serverless tools that are very popular are Claudia.js and AWS Lambda. Talking about Claudia first. Claudia is a serverless tool used for deployments for AWS Lambda and API Gateway. This tool automates error-prone deployments and configuration tasks and also contains tools such as Claudia Bot Builder and Claudia API Builder. So features of Claudia are, as you can see on my screen. It lets you deploy and update using a single command. It reduces the boilerplate code. With the help of this tool, you can also manage multiple versions and you can use standard NPM packages and do not have to learn Swagger. So that was about Claudia. Now moving forward to the last tool, that is AWS Lambda. AWS Lambda is basically a tool which provides infrastructure-less servers for your microservices builds, and the user is charged based on the pay-per-usage rate. This tool can be used in combination with the AWS API Gateway to host a REST API service, and with the help of this, you can serve any request made by the users. So if you ask me a few features of AWS Lambda, then I would say this tool enables you to run your code in response to the events and automatically manage the dependent compute resources. It lets you run the code without managing the service, so it pays as you use the service and you only pay for the compute time consumed. This tool scales an application automatically by running a code for each trigger. And finally, I would say this tool can be used to build a serverless backend for processing mobile API and web requests.
At number 10, we have microservices making it easy to build and maintain applications. when the products that developers are working on become somehow stable and is actively used by the customers, the daily work of the team splits in three different activities: new feature implementations, bug fixings, and changes of existing features. So, if the code is organized in a monolithic structure, chances are very high that the continuous integration, delivery, deployment pipeline will reflect the same structure, which means that each and every change to the code base will need to pass through the test or build steps that are totally unrelated to the change itself. So, microservices resolve such organizational based issues and make it easy to debug and test applications. With smaller modules going through a continuous delivery and testing process, your ability to deliver error free applications is vastly improved. On number 9, we have microservices providing continuous delivery. Unlike monolithic applications in which dedicated teams run on discrete functions such as UI, database, server-side logic, and technological layers, microservices use continuous delivery model to handle the entire life cycle of an application. So when developers, operations, and testing teams work simultaneously on a single service, testing and debugging becomes easy and instant. With this approach of incremental development, code is continuously developed, tested, and deployed, and the code is used from existing libraries instead of reinventing the wheel. It's simple, right? Just to make the changes than reinventing the wheel. At number 8, we have flexibility to use various tools for the required task. A microservice environment fosters an attitude of using the most appropriate technology for the specific needs of a service. Each service uses its own language, framework, or ancillary services while still being able to communicate easily with the other services in the application. So, what does it mean? So, suppose you have an application of n services. So, in that, Service 1 can be built on Python, Service 2 can be built on Java Service, Service 3 can be built using C Sharp, and so on. Each service have their own technology framework and are still being able to communicate through the complete application. So now, next in the list at number 7, we have microservices offering cross-team coordination. Unlike traditional service-oriented architectures, which typically involves heavyweight inter-process communications protocols, microservices make entire application decentralized and decoupled into services that act as separate entities. So microservices have various teams handling various entities, and then they communicate with each other to handle different functionalities for the application. Coming to number 6, we have microservices providing higher quality code. Well, modularizing an overall solution into discrete components help application development teams focus on one small part at a time. So this simplifies the overall coding and testing process. At number 5, we have microservices providing granular scaling. When talking about scalability, microservices seem to outperform many other architectural choices out there. Since each service is a separate component, you can scale up a single function or a service without having to scale up the entire application. Business critical services can be deployed on multiple servers for increased availability and performance without impacting the performance of other services. So, microservices make it easy to identify scaling bottlenecks and then resolve those bottlenecks at a per microservice level. So, whenever you feel the urge to scale some part of the system, you can decide to spin new small machines that will host only the service that provides the needed feature and nothing more. At number 4, we have microservices reducing risk. In the microservice framework, each service is a separate entity. So, this framework allows localized changes and higher confidence in quality and end-to-end regression scenarios. Basically, even if one service or the component of the application is down, then the complete application doesn't go down. Instead, only that particular services or components needs to be rebuilt by the developers. So, this reduces the risk of complete fall of the business of your application. At number 3, we have microservices promoting the best big data practices. Well, microservices naturally fit within a data pipeline oriented architecture which aligns the way in which big data should be collected, ingested, processed, and delivered.
Each step in a data pipeline handles one small task in the form of a microservice. So, if you have an application built with the microservice architecture, each microservice owns a private database to capture the data and implement the business functionality. Also, let me tell you that the databases of microservices are updated only to the Service API. Next comes the most important point. On number 2, we have microservices using minimal resources. Well, microservices allows you to optimize resources. With microservices, multiple teams work on independent services, enabling you to deploy more quickly. Development time is reduced and your team's code will be more reusable. So by this, decoupling services, you won't have to operate on expensive machines. Basic machines will do. The increased efficiency of microservices not only reduces infrastructure costs, but it also minimizes the downtime. Finally, on number 1, I have microservices popularity and offering high salaries. According to the Indeed.com, the average salary for a microservices ranges from approximately $97,000 per year for a software engineer and $116,000 per year for a senior software engineer. Also, many hypergrowth companies such as Netflix, eBay, Amazon, PayPal, Twitter use microservices in their architecture to scale their businesses. So guys, these were the key reasons that why you should learn microservices.
Why do we need design patterns? So to understand this topic, just consider a scenario where you have a team of developers, let's say 30 developers, right? Now you're given a project to basically build similar kind of applications. As a team lead, what will you do? You'll just divide these 3 applications to a group of 10, 10, 10 developers, right? So the group 1 will have project 1, group 2 will have project 2, group 3 will have project 3, and all these 3 groups will have each of 10 developers, right? So now when this team of developers start developing the application, they can follow different set of processes, right? So when I say process, what I mean that is the way they're developing the application, right? So they can follow a particular path to develop an application, right? So let's say the group 1 is following process 1, group 2 is following process 2, and group 3 is following process 3, right? Now, what can happen is that maybe process 1 works completely fine. What I mean by that is that, there's no error, and then whatever errors are coming, also there's no latency time, there's no disadvantage in using that kind of process, right? But if you consider any other 2 processes, let's say process 2 and process 3, it may happen that, there could be few errors, and maybe that's not the right way to build the application, right? So what could happen is that, I'm not saying that, process 1 is the only way to build an application. Maybe they have a better way when compared to process 2 and process 3, right? So as a team lead, what you clearly understand is that, your development team cannot build the application using process 2 and process 3, right? So to ensure that all the teams follow the same process or maybe a same pattern, you can use this concept of design patterns when the teams working on various projects use the same pattern to build similar applications, right? So basically, they'll select a particular pattern and they'll build all the applications based on that particular pattern itself. On that particular pattern, you'll make sure that you have the maximum advantages that you can get for your application, right? So that is the need of design patterns, guys. Basically, if you have to understand the need in a single line, then you can just understand the fact that design patterns are used to make sure that your complete team is on the same plate and everybody is following the same process or maybe the same pattern to build the application, right? So I hope you've understood what is the need of design pattern, right? So now let's understand what exactly design patterns are. With my previous explanation, you might have clearly understood that, design patterns are basically a simple pattern based on which you build an application. But yet, if I have to define design patterns for you, then design patterns or software design patterns can be defined as a software template or a description to solve a problem that occurs in multiple instances while designing a software application or a software framework, right? So I hope you've understood what exactly design patterns are. They're basically just a software template or a pattern or maybe a description to solve a particular problem. And that particular problem is seen in multiple instances, right? So when you want to solve a problem which is in multiple instances, you can go forward and choose the design patterns, right? So now that you know what are design patterns, let's move forward with principles behind microservices. So the principles behind microservices are, as you can see on my screen. It starts with independent and autonomous services, basically because each service is independent of the other service, right? That is because each service is either created for a domain or a business capability, and each service has its own functionality, right? So that is the first principle. Coming to second principle, that is scalability. So when you build microservices, what you can basically do is, for example, let's say you have 4 services for a specific business domain. Then what you can do is you can scale a specific service individually without scaling the others, right? So let's say in the example that I took, that is the e-commerce application, we had 3 services, right? Customers, orders, and product. So if you want to scale the customer service individually, you can definitely go forward and scale that particular service, and you do not have to scale the orders or the product service. Similarly goes for the other services also. Coming to the third principle, that is decentralization. So decentralization is basically when you do not have a centralized architecture, right? What I mean by that is for a specific business domain, when you build an application using microservices, your complete control is not there for a specific service, right? So all the controls are basically divided into individual services. Coming to resilient services, I would say microservices are resilient services because, let's say even if one service is completely down, the complete application will not go down. So in the e-commerce application, let's say if the product service is down, that doesn't mean that, your application will stop working. Only that particular service is not working, and the team will be working on that particular service to get back the service, right? So the only point that you have to understand is that, even if a service goes down, the complete application doesn't go down. Next we have is real-time load balancing. So obviously when a client sends a request, it may happen that, you have to retrieve data from multiple services. Over there, the load balancer comes into the picture, and then it defines how much CPU or how much GPU should be used for a particular service to get the data, and similarly how the client's request should be passed, right? So that's happening real time, and in this kind of architecture, the client doesn't have to wait for a really long time, right? So you get the outputs within seconds. Coming to availability, I think the principle itself defines its functionality. It basically means that the services are available 24/7, and all these services can be basically used as much as they want, right? Coming to the input, right? So once you understand DevOps, you'll understand how to deploy a service and how to get the outputs, right? After that, we come to the next principle, that is seamless API integration and continuous monitoring. All the microservices have a specific API gateway, which is basically the entry point to the client's request, right? So whatever client's request has been sent, it will be first sent to the API gateway, through which the request will be forwarded to the specific microservices. And obviously these microservices are continuously monitored whether the response is sent back or not, or maybe if the service is down or not. Coming to the next principle, that is isolation from failures. So when I say isolation from failures, what I mean by that is, all the services, even if they're down or maybe if they have any specific errors, that particular service will solve its own error and it won't disturb the complete application. So let's say in the e-commerce application that we considered, let's say if the product service is facing few errors, then what will happen is only that particular service will be basically taken into account and the errors will be solved, and those errors will not affect the application or maybe the other 2 services. Coming to auto provisioning is basically the ability to deploy the information by itself, right? So basically the service will generate the information for the client's request automatically without anybody's help, right? So guys, these were the basic principles behind microservices, that is independent and autonomous services, scalability, decentralization, resilient services, real-time load balancing, availability, continuous delivery through DevOps integration, seamless API integration and continuous monitoring, isolation from failures, and auto provisioning, right? So guys, I hope you've understood the principles behind microservices, right? So now once you start building microservices, you often face few challenges because of which you have to start using design patterns. So since this session is basically based on microservices, we'll be looking into the microservices design patterns. So let's get started with the first design pattern, that is aggregator. So when you hear the term aggregator, what comes onto your mind? In computing world, aggregator refers to a website or a program that collects related items of data and displays them, right? So even in microservices pattern, aggregator is basically a web page and invokes various services to get the required information or achieve the required functionality. Apart from this, when you basically build a microservices architecture, maybe a microservices application, by breaking down the monolithic application or the monolithic architecture, the source of output gets divided, right? So when I say monolithic architecture, you can just consider it to be a one big block, right? So when you break that one big block into small services, the source of output also gets divided, right? So this pattern basically proves to be beneficial when you need an output by combining data from multiple services. So if you consider a client sending a request, and maybe if we need data from two services, then aggregator is a design pattern that you should go for, right? Now, how do you think that happens? So what basically happens is that, let's say we have two services. When a client sends a request and maybe that, we want the data from both these services. So what will happen is that both these services will be having their own database. So with the help of aggregator design pattern, what will happen is that, each transaction will have a unique ID. So based on that particular ID, the request will be sent and all the data will be collected from the individual services and the required business logic will be finally applied. After that, what will happen is that, whatever data is collected, it will be published to the REST endpoint. And later on, what will happen is that the data will be consumed by the respective services which require that data, right? So it could be a specific consumer or maybe a user or maybe a group of users or so on, right? So if you have to understand aggregator pattern, guys, it's really simple. So aggregator pattern is basically a web page which invokes various services to get required information. So whenever a client requires a specific information from 2 or 3 services, you can go forward with this aggregated design pattern. Also, before I move forward to the next design pattern, I would like to mention over here is that, aggregator pattern is basically based on the drive principle. So what happens is that, based on this principle, you can abstract the logic, that is the business logic, into composite microservices and aggregate that particular business logic into one service, right? So let's say you have a business logic, right? So that particular business logic, what you can do is maybe you can put that particular business logic into 2 to 3 microservices. Later on, what you can do is you can aggregate that business logic into one specific service, right? So for example, if you consider two services, service A and service B, then you can individually scale the services simultaneously by providing the data to the composite service, right? So that was about the aggregated design pattern, guys. Let's move forward with the next design pattern, that is API gateway. Now, microservices are built in such a way that, each service has its own functionality. But when an application is broken down into small autonomous services, there could be a few problems that a developer might face. Now, the problems could be, how can I request information from multiple microservices? How can different UIs require different data to respond for the same backend database service? Or how to transform data according to a consumer requirement from reusable microservices? Or how to handle multiple protocol requests, right? So guys, these are basically few problems that all the developers face. Well, if you wish to solve these problems, then I would say the solution to these kind of problems could be the API gateway design pattern. So the API gateway design patterns addresses not only the concerns that I mentioned right now, but also it solves many other problems. This particular pattern can be considered as a proxy service to route a request to the concerned microservice. So basically, as I mentioned before, API gateway is the entry point to the client's request. Also, being a variation of the aggregator service, it can send a request to multiple services and similarly aggregate the result back to the composite service or the consumer service, right? So the API gateway, as I mentioned, is basically at the entry point for all the microservices and can create fine-grained APIs for different types of clients, right? So maybe you have a client sending a specific request, or maybe the client B sends a different kind of request, right? So with the help of this particular pattern, you can create fine-grained APIs for all different kinds of clients and for the requests. Also, since developers are always concerned about, how to handle multiple protocol requests, API gateways can convert the protocol request from one type to another type. Similarly, it can also offload the authentication responsibility of a specific microservice. So once the client sends the request, these requests are basically passed to the API gateway, which acts as an entry point to forward the client's request to the appropriate microservices. Then, with the help of the load balancer, the load of the request is handled and the requests are sent to the respective services, right? So microservices also use the service discovery, which basically acts as a guide to find the route of communication between each of them. So when I say each of them, I mean two microservices. So microservices can communicate with each other via stateless server, that is either by HTTP request or message bus, right? So with the help of API gateway pattern, guys, a client's request is basically forwarded to the correct microservice. And even if there are different kinds of clients using different UIs or maybe different protocols, and they want the data from the same backend service, then API gateway design pattern is your solution, right? So I hope that you've understood what is API gateway design pattern. Now let's move forward with the next design pattern, that is chained or chain of responsibility. So the chained or chain of responsibility design pattern basically produces a single output, which is a combination of the multiple chained outputs. I hope that is clear to you guys, right? So as the name suggests, in this particular design pattern, what happens is that the client request is passed to, let's say, service A, and then the request is passed to service B, and then the request is passed to service C. Similarly, the response is first collected from service C to service B, and then from service B to service A, and finally it goes to the client, right? So as the name suggests, guys, the chained or the chain of responsibility design patterns produces a single output, which is a combination of the multiple chained outputs. So for example, if you have 3 services lined up in a chain, then the request from client is first received by service A, and then this service communicates with the next service, service B, and collects the required data. Finally, the second service communicates with the third service to generate the considered output. And what happens is that all these services response is sent again from service C to service B to service A, and finally to the client, right? So all these services use synchronous HTTP request or response for messaging. Also, until the request passes through all the services and the respective responses are generated, the client does not get any output, right? So guys, this is kind of a disadvantage in this particular design pattern because, let's say, you have 20 services lined up. And maybe the client request is a very big request, right? So until all the data is collected from all these particular services and then the response back is generated, the client does not see any output, right? So it's always recommended not to make any long chain as the client has to wait until the chain is completed, right? But before I move forward to the design pattern, one more important aspect which you need to understand is basically that, the request from service A to service B may look completely different from how the request is from service B to service C. Similarly is the case for response. Maybe the response from service C to service B may be completely different from service B to service A, right? So that's what you have to understand about the chain of responsibility or chain design pattern, guys. Now, let's move forward with the next design pattern, that is asynchronous messaging design pattern. So what do you understand by this term asynchronous messaging? Obviously, the messaging pattern between microservices is not synchronous, right? So in the previous design pattern, we had discussed synchronous messaging, right? So that was because, service A communicates with service B and B to C, right? But in asynchronous messaging pattern, it's not necessary that, all the services communicate like, service A to B or B to C. Maybe service A can directly communicate service C, and maybe service C can communicate with service B, or maybe service B does not communicate at all, right? And service B communicates with service A, right? So basically what you have to understand is that, since the client waits a long time without any output in synchronous messaging, and maybe you do not want the client to wait for a long time, this is where basically you use the asynchronous messaging design pattern, right? So in this particular pattern, what happens is that all the services communicate with each other, but maybe they do not have to communicate with each other sequentially. So if you consider 3 services, as I just mentioned before, service A, B, and C, the request from client can be directly sent to service C and service B simultaneously. When I say simultaneously, what happens is that, the single request from client is sent to both the services together, that is service C and service B. So then what will happen is that, these requests will be in a queue. So when I say queue, you can understand that, it's basically a line of requests. So when a client request is simultaneously sent to 2 services, you basically build a queue. And apart from that, what you also have to understand is that, let's say the service A sends a request to service C. It's not necessary that, service C sends back a response to service A itself. Maybe it can follow a different path and then finally a response can be sent, right? So the path is not defined and it is not done sequentially in asynchronous messaging pattern, right? So guys, that was about asynchronous messaging design pattern. Next, let's move forward with the next design pattern, that is database design pattern or shared data design pattern. Now, for every application, there's obviously a humongous amount of data present, right? So when we break down an application from its monolithic architecture to microservices, it's very important to know that, each microservice has a sufficient amount of data to process a request, right? So I hope that point is clear to you. When we break down the monolithic application into small services, we need to make sure that, each microservice has sufficient amount of data to process the client's request. So either the system can have the database per each service or it can have shared database per service, right? So when I say database per service, what I mean that is, each microservice in the system will have a specific database for themselves. And shared database per service is basically when 2 or 3 microservices together share a specific database, right? Now you can use the database per service or shared database per service to solve various problems. So the problems could be basically the duplication of data and inconsistency. Different services have different kinds of storage requirements. So the problems could be basically the duplication of data and inconsistency. Different services have different kinds of storage requirements. Few business transactions can query the data with multiple services, and denormalization of data is not easy, right? So to solve these kind of problems, basically you can use the database per service or the shared database per service, right? So if you have to solve, let's say, the duplication of data and inconsistency, and maybe different services have different kinds of storage requirements, or maybe a few business transactions can query the data with multiple services, I think you should go for database per service, as it will then be accessed by Microservices API itself, right? So each microservice will have its own database ID, which thereafter prevents the other services in the system to use that particular database, right? So only that particular microservice can access a specific database present for that particular microservice itself, right? So apart from this, to solve the issue of denormalization, you can go forward with the shared databases per service to align more than one database for each microservice. So what will happen is that this will help you gather data for the monolithic applications, which are broken down into microservices. But you have to keep in mind that you have to limit these databases to 2 or 3 microservices, else scaling these services will be a big problem, right? So guys, that was about the database design patterns. Let's move forward with the next design pattern, that is the event sourcing design pattern. So the event sourcing design pattern basically creates events regarding the changes in the application state. So these events are stored as a sequence of events to help the developers track which change was made when and by whom, right? So with the help of this, you can always adjust the application state to cope up with the past changes. And also you can query these events for any data change and simultaneously publish these events from the event store, right? So once the events are published, you can see the changes of the application state on the presentation layer, right? So that was about event sourcing design pattern, guys. Event sourcing design pattern is basically used to create events regarding the changes in the application state, right? You've done a specific change and maybe you want to go back to the previous change that you have done. You can always use this particular kind of pattern to go back and see what changes was made and when and by whom, right? So that was about event sourcing design pattern, guys. Let's move forward with the next design pattern, that is branch pattern. So what do you understand by branch pattern? Obviously, as the name suggests, it's all about branches, right? So for a specific service, you can have different branches, right? So the branch microservice design pattern is basically a design pattern in which you can simultaneously process the request and response from 2 or more independent microservices. So unlike the chain design pattern that I discussed before, the request is not passed in a sequence, but the request is passed to 2 or more mutually exclusive microservices chains, right? So this design pattern basically extends the aggregated design pattern and provides the flexibility to produce responses from multiple chains or a single chain, right? So for example, if you consider an e-commerce application, then you may need to retrieve the data from multiple sources. And this data could be a collaborated output from various services, right? So you can use the branch pattern to retrieve the data from multiple sources, right? So the branch pattern is really simple to understand, guys. It's basically where you want to simultaneously process the request and the response from multiple microservices, right? So these could be either in a single chain or maybe it could be in multiple chains also. But yes, it's not necessary that the request or the response is done in a sequential manner. So guys, that was about the branch pattern. Now let's move forward with the next pattern, that is command query responsibility segregator design pattern. So command query responsibility segregator design pattern, or more commonly known as CQRS, is basically used when you want to query for a specific data, right? Now what happens is that when you have microservices design in the form of database per service or shared database per service, what happens is that you have limited access to database, right? So basically you cannot implement a query as the data is limited to only a single database. So in such scenario, we basically use the CQRS pattern. So according to this pattern, what happens is that the application will be divided into 2 parts, that is command and query. So the command part will basically handle all the requests related to create, update, and delete, while the query part will take care of the materialized views, right? So the materialized views are updated through a sequence of events which are created using the event source pattern that I just discussed before. So in the CQRS pattern, guys, you basically divide the application into 2 parts, that is the command and the query. The command will take care of the requests related to create, update, and delete, and the query part will basically take care of the materialized views, right? So with the help of this pattern, you can make sure that you have good access to your databases and then the client's request is satisfied. Also, you can make sure that your materialized views are updated through a sequence of events which are again created using the event sourcing design pattern. So guys, that was about the CQRS pattern. Now let's move forward with the next pattern, that is circuit break pattern. So the circuit break pattern, as the name suggests, is basically used to stop the process of request and response if a service is not working. So for example, let's say a client is sending requests to retrieve data from multiple services, but due to some issues, one of the services is down. Now, there are mainly two problems which we'll see. First, the client will not have any knowledge about the service being down, right? So he or she will be continuously sending the request to that particular service. The second problem that we see is basically the network resources will be exhausted with low performance and bad user experience, as the client, without knowing, will be waiting for the response to come back, right? So to avoid such problems, what you can do is you can go forward and use the circuit breaker design pattern. So with the help of this design pattern, the client will invoke a remote service via a proxy. The proxy will basically behave as a circuit barrier. So whenever the number of failures cross the threshold number, the circuit breaker trips for a particular time period, and then all the attempts to invoke the remote service will fall in this timeout period, right? So once that timeout period is finished, the circuit breaker will allow a limited number of tests to pass through, and only if those requests are succeeded, the circuit breaker resumes back to the normal operation, right? So just in case if the tests don't go through, then there'll be a failure and the timeout period will begin again, right? So in this particular pattern, what you have to understand is basically that, when the number of failures cross a threshold number, the circuit breaker will trip for a particular time period, and then all the attempts to invoke that particular service will fall in that particular period, right? Once that time period is done, what will happen is that, the circuit breaker will allow a limited number of tests to pass through, and only if the tests succeed, it will resume back to normal operation, else it will show failure again, and again the timeout period will begin again. So with the help of circuit breaker pattern, guys, you can make sure that, there's no exhaustion of the network resources with low performance, and always the user experience is kept at a good note, right? So that was about the circuit breaker design pattern, guys. Now let's move forward with the last design pattern for today's session, that is decomposition design pattern. So microservices are basically developed with an idea on the developer's mind to create small services with each having their own functionality. But breaking an application into small autonomous units has to be done logically, right? So to decompose a small or a big application into small services, you can go forward and use the decomposition patterns. So with the help of these patterns, either you can decompose an application based on the business capability or based on subdomains. So for example, if you consider an e-commerce application, then you can have separate services for orders, products, and customers if you decompose by business capabilities. But in the same scenario, if you design the application by decomposing by subdomains, then you can have services for each and every class. So here in the example that I had considered before, that is the e-commerce application, if you consider a customer as a class, then this class will be used in customer management, customer support, customer query, and so on, right? So to decompose, you can use the domain-driven design through which the whole domain model is broken down into subdomains. Then each of these subdomains will have their own specific model or a scope, that is basically the bounded context. So now when a developer designs microservices, he or she will design those services around that particular scope or bounded context, right? Either you can decompose microservices by business capabilities or by domains, right? Now, obviously, these patterns might be sounding very feasible to you. But yes, these patterns are not feasible for a big monolithic application. This is because of the fact that, identifying subdomains or business capabilities is not an easy task for big applications, right? So the only way to decompose big monolithic applications is by following the vine pattern or the strangler pattern. So the vine pattern or the strangler pattern is basically based on the analogy to a vine, which basically strangles a tree that it is wrapped around, right? So when this pattern is applied onto web application, a call goes back and forth to each URI call, and a service is broken down into different domains. These domains are then hosted by separate services, right? So according to the strangler pattern, two separate applications will live side by side in the same URI space, and one domain will be taken into account at an instance of time. So eventually what happens is that, the new refactored application basically wraps around, or you can say strangles or replaces the original application until you can shut down the monolithic application.
The basic system requirements that I may suggest for you is that you have a minimum memory of 512 MB to 1 GB, a Java version of 1.8.0, a processor speed of minimum 800 MHz to 1.5 GHz, and a free disk space of minimum 300 MB. Now, as we have seen, that Java is a basic system requirement, Before I move forward to tell you how to download and install Java, let me brief you a little bit about Java. Well, Java is a programming language and a computing platform released by the Sun Microsystems in the year of 1995. So just in case, if you want to run any Java applications, then Java runtime environment is fine. But if you also want to develop Java applications, then you must install Java Development Kit. Now let us get into how to download and install Java. To download and install Java, open your favorite browser and type Java JDK. The first website that you see is from the Oracle website. Underneath the link, you see that there are various options provided by the Oracle website to download different versions of Java, such as Java SE Development Kit 8, Java SE Development Kit 9, JDK 7, etc. In this video, I would be downloading Java SE Development Kit 8. So click on it. Once the website opens, you see that the Oracle website offers different versions of Java to download for various operating systems such as Linux, Solaris, Mac OS, and Windows. In this video, I would be downloading for Windows with 64-bit. So before you click on the executable file, what you have to do is accept the license agreement by clicking on this radio button and then click on this downloadable executable file. So click on it. You see that Java starts downloading. So until Java is being downloaded, let me show you how to check your system properties. So go to Start, right-click on this PC, go to More and Properties. You'll see a control panel window opening up showing the basic information about your computer, such as processor, installed memory, system type, etc. In my case, I have a Windows with 64-bit operating system and with an 8 GB RAM. So let me minimize this. Okay, now the executable file has been downloaded. So let's go to Downloads. And you see that Java has been downloaded. Double click on this. Now we can see that there's a wizard which opens up which says welcome to the installation of Java SE Development Kit 8. Click Next. Make sure that you choose the development tools and again click Next. Here Java starts installing. Now choose the destination folder. In my case, I've chosen C Program Files Java and click Next. After Java has been installed, you see a wizard which opens up and says Java Development Kit 8 has been successfully installed. Click on Close. Once Java has been installed on your PC, you have to set the environment variables in Java. For that, go to Start, right-click on this PC, go to More and Properties. A control panel window opens up showing all the basic information. Now, click on Advanced System Settings. Here, go to Environment Variables. And over here, add a new variable by clicking on the option New and type the name as Java _ home. In the variable value, add the directory of your Java JDK folder. So let's go to this PC, C, Program Files, Java, JDK, right click here, copy the address and paste it over here. Click on OK. After this is done, you also have to edit the path variable. So go to Path, click on Edit and over here append the Java bin folder. So go to bin, right click here, copy the address, click on here and paste. Once it is pasted, click on OK and even in this window, click on OK. Finally, to check whether Java has been installed or not, go to command prompt and type Java space -version. You can see that the Java version 1.8 has been installed. So that is how you can download and install Java. Now let's move further and see two different approaches to run the Spring Boot projects. The first approach I'm going to explore for you guys is by using a Spring Startup plugin in Eclipse, and the other approach I'm going to explore for you guys is by using a Spring Boot CLI with Apache Maven. So let me start with the first approach. Before we get into how to download and install Eclipse and use the Spring Startup plugin in it, let me just brief you a little bit about Eclipse and the tool we're going to use. Well, Eclipse is an integrated development environment containing a base workspace and an extensible plugin system for customizing the environment. So basically, you can deal with various kinds of projects like web-based projects, Android applications, software projects, and others. Coming to a Spring Startup plugin, that is the Spring Tool Suite, is an Eclipse-based development environment that is customized for developing Spring applications. So it is basically a ready-to-use environment to implement, debug, run, and deploy Spring applications. Now let us start by downloading and installing Eclipse. To download and install Eclipse, go to your favorite browser and type Eclipse IDE for Java EE developers. Open the first link that shows up, that is from the official website of Eclipse. As the page opens up, on the left side you can see that there's a list of various Eclipse releases, and on the right side there's a list of various download links. In this video, I'm going to download for Eclipse Oxygen package since it's the latest one. So click on Oxygen packages. Now, in the next link that opens up, click on Eclipse IDE for Java EE developers. Now, on the right side from the download links list, choose according to your operating system. Since I have a Windows with 64-bit, I'll click on Windows with 64-bit. In the next page that you're redirected to, click on this download button. Well, you can now see that Eclipse JE Oxygen has started downloading. Okay, now you can see that Eclipse Oxygen has been downloaded. So let's go to downloads again, and you can see that the Eclipse has been downloaded here. So let's extract these files to a specific folder, let's say C, click on OK. Now you can see that Eclipse folder is getting extracted to the C drive. Now let's minimize this and go to C drive. You see that there's a folder named Eclipse. Open this, and here inside the folder you can see an application file of the name Eclipse. So double click on it. This launches the Eclipse application. Choose the directory for your Eclipse workspace, like I have chosen C user Sahiti, and then click on Launch. Well, now your Eclipse application has started. To download the Spring Startup plugin, go to Help, go to Eclipse Marketplace, and type Spring Tool Suite. Over here, click on Install. A dialog box opens up with various options. Make sure you have selected all the options and click on Confirm. Click on this radio button to accept the license agreements and then click on Finish. You can see at the bottom that the software starts installing. If you get this warning, click on Install anyway. This will continue your installation. Now, after the software has been installed, a dialog box opens up which says Restart Eclipse. So click on Restart Now. So finally, you can see that your Eclipse has restarted. Now, to create a Spring Boot project, click on File, go to New, and choose Spring Startup Project. Now, a window opens up. In this window, you have to choose the following for your project, such as name, group ID, artifact ID, etc. So let's suppose I choose the name as hello_world and the group ID as com.edureka. And make sure the package here is a combination of the group ID and the name. So package name would be com.edureka.hello_world. Make sure you have chosen Maven as a type and click on Finish. In this window, you have to choose the dependencies for your project. So let's suppose I choose Web and then click on Finish. On the left side in the Project Explorer, you can see that the Spring Tool Suite has created a Spring Boot project for us. Now let us explore the project structure of this project. Well, this project has an auto-created Java file which acts as an entry point for the application. This project also has a pom.xml file which houses all the dependencies required for this project. Now, this application is ready as a standalone application and we can definitely launch it, but I would be adding a configuration Java file to it so that it can handle HTTP requests. So to add the file, go to the package, right-click on this package, go to New, and choose Class. In this window, choose the name of your Java file. Let's say application configuration file. Click on Finish. Now, here, to handle the HTTP request, we need to import two annotations that are the REST controller and request mapping. So to import these, let's type import space org.spring framework.web.annotation.request mapping and put a semicolon at the end of it. Similarly, also import the REST controller. So for that, type import space org.spring spring framework dot web dot bind dot annotation dot rest controller. After importing both the annotations, create a method inside the configuration class which can be called when an HTTP request is made. So type @request mapping and in brackets and double quotes. Let's suppose I want to pass the request /hello. Now create a method with a string. Now let's suppose when we pass the request /hello, we want to return hello world. Let's type hello world and close the brackets and save this file. Now to run this project, right click on this project, go to run and choose a Spring Boot app. At the bottom of the console, you can see that Tomcat has started on port number 8080 and the Hello World application has started. To check whether the application is working or not, go to the browser and type localhost :8080/hello. You can see that the output comes as Hello World. This means that our application is working. Now let me show you the second approach, that is by using Spring Boot CLI and Apache Maven. But before that, let me brief you a little bit about Maven and Spring Boot. Maven is a powerful project management tool that is based on project object model. It is basically used for projects build, dependencies, and documentations. Coming to Spring Boot CLI, Spring Boot makes it easy to create Spring-powered production-grade applications and services. Now, let me show you how to download and install Maven first. To download Maven, go to your browser and type Apache Maven download. Click on the first link that opens up. Now scroll down and go to the file section. Here, choose the zip file that you want to download. Let's say Apache Maven 3.5.3 binzip. On the left side, you can see that Maven has started downloading. Okay, now let's go to downloads. You can see now that Maven has been downloaded. Let's extract these files to a specific folder. Let's say C and click OK. Let's go to C drive now. And now you can see that the Maven files have been extracted to the C folder. Similar to Java, you also have to set the environment variables for Maven. So for that, go to Start, right click on this PC, go to More and Properties. A control panel window opens up. Go to Advanced System Settings, click on Environment Variables, and here add a new variable with the name m2_home. In the variable value, add the path of your Maven folder. So go to the folder, right click here, copy the address and paste it here. Click on OK. Once it is done, also add one more variable with the name maven_home pointing to the same path. So click on New and type maven_home and paste the same directory here. Click on OK. Once it is done, you also have to edit the path variable. So go to Path, click on Edit, and now over here, add the directory of the Maven bin folder. So open bin, copy the address, click on New and paste it here. Then click on OK and again click on OK. Once this is done, to check whether Maven has been installed or not, go to command prompt and type mvn space -- version. You can see that Apache Maven 3.5.3 has been successfully installed. Now, to install the Spring Boot CLI, what you have to do is go to the browser and type Spring Boot CLI download. Open the first link that you can see on the browser. Scroll down and under the manual installation, download this zip folder. So click on that and you can see that Spring Boot CLI zip folder is getting downloaded. Once it's downloaded, go to Downloads and extract these files to a specific folder, let's say C, and click on OK. Once the file has been extracted to C drive, you can see a folder named Spring 2.0 Release. Similar to Maven, you also have to set the environment variables for Spring. So for that, go to Start, right click on this PC, go to More and Properties. In the control panel window, go to Advanced System Settings, click on Environment Variables, and now over here, add a new variable with the name Spring_home. So type Spring_home and in the variable value, add the directory of the Spring folder. So right click here and copy the address and paste it here. Click on OK. Once this is done, You also have to update the path variable and append the Spring bin folder. So go to Path, click on Edit, and go back to the folder, choose Bin, right-click here, copy the address, click on New, and paste it here. And again click on OK. Then click on OK. Once this is done, to check whether Spring has been installed or not, go to Command Prompt and type Spring space hyphen hyphen version. You can see that Spring CLI version 2.0 release has been installed. Now, to run your Spring Boot projects, what you have to do is you have to change the working directory of your command prompt to the project directory. So let's suppose I have a project on the desktop. I'll open it. I'll right click here. I'll copy the address. I'll go back to command prompt. I'll type the command cd space and paste the address here. Now click on enter. This changes the working directory of your project. Now, to run the Spring Boot project, you have to type the command mvn space spring hyphen boot run and click on enter. This starts building your Spring Boot project. Once this is done, at the end of the console, you can see that the Tomcat has started on port number 8080 and the application Hello World has started. Now to check whether our application is working or not, let's go back to browser and type localhost 8080/hello. This prints Hello World. That means the application is working fine.
So the first challenge that we are going to discuss is called perceptibility. Now, as we know that in a microservice, there are small components to deploy and maintain, and there are many of them. So there are many small components that we need to deploy and maintain. And at times it becomes very difficult, guys, to monitor and identify problems, right? If I take the classic example of an e-commerce website, so over there we have multiple small services running. For example, the card service, it can be the product service or the customer service. So there are multiple services running, and we need to deploy and maintain those services. So at times it becomes very difficult to monitor and identify problems. So what we require great perceptibility around all of these components. The next challenge is configuration management. Now there is a great need to maintain the configurations for the components across the various environments, because we have small components, right? The idea behind microservices is to break down an application into small composable pieces that can talk to each other. So we need to configure these components across various environments. That is also one very big challenge, guys. Now the next challenge is debugging. Now it becomes very difficult to probe each and every service for an error, right? So you have multiple services running. Now to debug error in each of those services is very difficult. So what we need centralized logging and dashboards to make it easy to debug the problems, right? Then the next challenge that we are going to discuss is basically consistency. Now think about it, guys. You cannot have a wide range of tools solving the same problem, right? And we know that it is important to foster innovation, but we also know that it is also important to have some decentralized governance around the languages, platforms, technology, and tools which are used for implementing or deploying or even monitoring the microservices, right? So I hope you're getting my point. So maintaining consistency is also a very big problem. Now the next point is automating the components. It becomes very difficult, guys, to automate everything because there are a number of smaller components instead of a monolith. That is build, deployment, and monitoring. So in order to automate this entire cycle, it's very difficult. So these are the challenges with the microservice architecture. Now let us see the solution. So solution is Spring Boot. Now Spring Boot enables building production-ready applications quickly and provides many non-functional features. Let me discuss a few of them. So the first feature that I'm going to talk about is embedded servers. So these servers are easy to deploy with the containers. Then the next point is it helps in monitoring multiple components. So you have various components, you have various services running. So in order to monitor those services, we can do that with the help of Spring Boot. Then finally, it facilitates in configuring the components externally. So we saw whatever the challenges were, right? The consistency, perceptibility, configuration management, automation, and all the challenges that we have just discussed were completely removed with the help of Spring Boot. So let's move forward, and now we are going to focus on how to build a top sports brand. So this is our use case, guys. We'll be building a top sports brand. Let us see how we are going to do that. So in this Spring Boot microservice example, we'll be creating top sports brand application, which will have 3 services. So you can see it in the diagram as well. So we have 3 services here. One is Edureka server, then we have item catalog service, and then we have edge service. So these are the 3 services that we'll be running. Now let me discuss each of these one by one. So the first thing is Edureka service. Now this service will register every microservice, and then the client microservice will look up to the Edureka server to get a dependent microservice to get the job done. So what I mean by that is a user will approach this Edureka service, which will have the other two services registered with it. So this is basically called a registry service. In this registry service, we have the other two services already registered. So based on what the user wants, Edureka server will get a dependent microservice to get the job done. So I hope you have understood that. Now let's move forward and we are going to focus on what our item catalog service. So item catalog service will generate the list of sports brands which are popular in the market. So whatever the list of sports brands that are popular, it will generate that. And then the edge service is also pretty much similar to the standalone item catalog service. However, it will have fallback capabilities which prevent the client from receiving an HTTP error when the service is not available. Right? I hope you have understood this architecture. Let me just repeat it once more. So we have a Edureka service, which is owned by Netflix. And this is basically a registry service. And we have the other microservices registered in this service. The item catalog service will have the sports brands. Then the edge service will basically give us the top sports brand, will filter only the top sports brand. This is how the architecture of our Spring Boot application is. So I've given the numbers as well in the diagram. So the first thing is it will register the other two applications in Edureka service. So first we'll register the item catalog, then we will register the edge service. Then we'll produce the sports brand names, this item catalog service, and the edge service will filter only the top sports brands. So this is what is going to happen in today's use case. Now let us see what are the tools I'm going to use. So I'm going to use Java 8, Eclipse IDE Oxygen, and the Spring tools. So let me just quickly open my Eclipse IDE and I'll explain you the code there. So this is my Eclipse IDE, guys, and over here I've already written the code in order to execute the use case. I'll just give you a walkthrough of what I've done here. So I have all the three services that I've mentioned in the slides. So we have Edureka service, we have edge service, and we have item catalog. So I'll start with Edureka service first. I've already written it. So I'll just quickly show you how you can do that. Click on new, over here go to other, and over here select Spring Starter Project. Click on next and just a couple of minutes, and then just give the name to your service and then go ahead, click on next. And the dependency, so we want the Edureka server as a dependency, and just finally click on finish. So that's all you have to do, and you'll find Edureka server already created. And over here, the first thing that I wanted to show you is application properties. So over here, I've mentioned the port. I've modified it a bit. So what modification I've done? I've modified the file to add a port number, and I've disabled the registration. The port number is 8761, and I've disabled the registration, right? Next, what I'll just open Edureka service applications.java, right? So for that, so this is the file that I was talking about. And over here, I've added a couple of notation. First is enable Edureka server above the Spring Boot application. So this Edureka server that you're seeing, I've added that above the Spring Boot application, right? So this annotation will configure a registry that will allow other applications to communicate. Since I want the other applications to obviously communicate with it, so it will basically configure a registry and it will allow the other applications to communicate. So that's all for Edureka servers. Let me just go ahead and quickly run it to show you how it looks like in the browser. So I'll just click on run as a Spring Boot application. And you can see that it has started running already. And I'll just quickly open my browser and at port 8761. So you can see that Edureka service is running at port 8761. But currently you can see there are no instances which are registered with Edureka, right? So we need the other two services to be registered here. So this is it for Edureka server. Now let me talk about item catalog. So for item catalog, what we need to do is again click on new, go to other, Spring Starter Project, like we have done it in Edureka service as well. Give a name, whatever name you want to give. Then in the dependencies, there are a lot of dependencies that we need to import. So let me just talk about that. The first thing we need to import is an actuator, right? So we need to click on this and we need to import this. So what is an actuator? It is a feature that will help us to monitor and manage our application. After actuator, I need to import Edureka Discovery. Yeah, so I need to import this Edureka Discovery for service registration. Since I want my service to be registered in the Edureka server, so for this I need to import this particular dependency. Then I'm going to import JPA, which is basically to save or retrieve data. After that, I'll import H2, which is an in-memory database. All right. Then I'm going to import the REST repositories. All right. So these REST repositories are basically to expose JPA repositories as REST endpoints. Then I'm going to import web. All right, so here we can see that we have web here. So web will basically is nothing but Spring MVC and embedded Tomcat. Then I'll import DevTools. All right, so this is to auto reload the application when there's any change in the file. Now I'm going to import Lombok in order to, just to reduce the boilerplate code. So since I've already done that, I won't create another project here, another service here basically. So let me just give you a walkthrough of the code that I've written here. So first, let me show you the item catalog application.java file. So this is how it looks like. First of all, the couple of annotations. So enable discovery client is basically to register my application in the Edureka server. Then we have one more annotation, Spring Boot application, right? And so after that, what I have written, so this is my main class, all right? The main class will be executed first in my application, and this is responsible for item catalog execution, the item catalog application execution. All right. Then I have few annotations at the rate data, all argument constructor. So in order to explain you that, let me just tell you what at the rate data is a convenient shortcut annotation that bundles the features of toString, equals and hash code, getter, setter, required argument constructor together. All right. So people who are familiar with Java know all these annotations. Then the second annotation I'm using is all argument constructor generator. So basically it will generate a constructor with one parameter for each field in your class. All right. So fields marked with at the rate not null result in a null checks on these parameters. Then we have no argument constructor will generate a constructor with no parameters. Yeah, after that we have at the rate toString. So it'll also pretty easy. So at the rate toString is basically, it gives you the facility so that you don't have to start a debugger to see your fields. You can just let Lombok generate a toString for you. And then the entity is basically is a lightweight persistence domain object. Typically, an entity represents a table in a relational database, and each entity instance corresponds to a row in that table. So the primary programming artifact of an entity is the entity class, although entities can use helper classes as well. So this is about the annotations. So the next thing that I'm telling you about is a parameterized constructor of the item class. So let me just write that here as well. So it is a parameterized constructor of the item class, and here we are defining the class members, a long ID and the string name. So next we have a repository REST resource. So basically we have an interface item repository that we are extending with JPA repository. Over here what we are doing, we are defining an implementation of the command line runner interface that will need to override the run method, and this method will be executed after the application context is loaded and right before the Spring application run method is completed. So this will basically generate the key value pair using the for each loop, and we are basically overriding the run method to print our key value pair. So that's what we are doing here. So I believe you have understood this code, or people who are familiar with Java, for them it's not a tough task, right? It's a pretty basic code. So so we are creating an item entity, a JPA repository for it, and we are also creating a command line runner to populate database with the default data. All right, so that's what we have done here. Now let me go to the application.properties, and I wanted to show you a couple of things there. So yeah, in this application.properties, what we have done, we have added an application name in the file to display the Edureka service and set the port to 8088. Now also in the cloud properties file, so let me just show you the cloud properties file as well. So you need to add all of these things in your cloud properties file as well. So this is the Edureka instance host name. Then we have the non-secure port mentioned here, the metadata map to the instance ID. Over here we have it. Then Edureka.instance lease renewal interval in seconds is 5. Then Edureka client region, it's a default region. Registry fetch interval seconds is we have given it as 5. So all of these things will be available with you. If you can mention your email ID in the comment section, you can find the entire code there. So mention your email ID in the comment section and we'll reply you with the entire code used in the video. Since I've configured at port 8082, let me just go ahead and quickly run this. First, I'll clean it using Maven. So I'll just click on Maven clean. And now I'm going to build it using Maven again. So just click on run as, go to Maven build. Over here, type spring -boot : run and just hit enter. So let me just go to the Edureka server. Let me just refresh this link once, right? So you can see that item catalog service is already registered in my Edureka server. Now let me just go to the port 8082/items. So it is displaying basically all the items present in my item catalog service, right? So let's just go through it. It's pretty easy, guys. So we have the name of the sports brand, right? Then we have again Bad Boys, and we have Air Jordan, Mike, Adidas, all the sports brands that we were talking about. And the size of the page, total elements and everything, you can have a look and just play around with it. So I'll just go back to my Eclipse IDE once more. So now we're going to create an edge service. Now edge service, as I've told you, it is pretty similar to the standalone item service that we have created. However, it will have fallback capabilities which will prevent the client from receiving an HTTP error when the service is not available. And how we are going to do that? Similar fashion, like we have created item catalog, all you have to do is click on file, go to new, and go to others, select the Spring Starter project here, click on next, give a name to your service, whatever name you feel like, then go to next. Then over here we need to add dependencies, so let me just tell you about that. The first dependency we need is Edureka Discovery. So just type here Edureka Discovery, select that, right? So this is basically for service registration like we have done in the item catalog service as well. So this will be registered in my Edureka server. Then we are going to add a fiend dependency. Let me just type that first. So yeah, so this fiend dependency is basically a declarative web service client. All right, and now once it is done, we are going to add Zool. So basically Zool provides an intelligent routing system. So just click on Zool as well. Once that is done, I'm going to import REST repositories. So these REST repositories, as I've told you earlier as well, it will expose the JPA repositories as REST endpoints. Then I'm going to again add web as well. So I've done that in the item catalog as well. So just click on web. This is basically a Spring MVC with Spring MVC architecture and embedded Tomcat, right? So like we have MVC and MVT architecture. Then I'm going to type in here Hystrix. So this Hystrix, just let me just check it once. Yeah. So it is a circuit breaker to stop cascading failure and enables resilience, right? So that's what it is used for. Then let's go ahead and add one more dependency, that is Lombok. Lombok is basically to reduce the boilerplate code that I've done in the previous project as well. So I'll just click on cancel because I have already done that. You can just go ahead and click on finish and you will find the edge service present here, something like this, right? So now let me just take you through the edge service as well. We know that the item catalog service is running on port 8082. So what we need to do, we need to configure this application to run on a different port. And now this is pretty obvious, guys, right? So let me just open this application.properties and you can see that I've configured it at port 8089, right? And I've given the application name for a similar reason, basically to add my service in the Edureka server, right? Now I need to create the cloud properties file that I've already done, right? You can see it over here, the cloud properties file. It is already present. And I need to add some code here that I've done it in the item catalog service as well. So this code, you can again find it once you mention your email ID in the comment section. We'll reply you ASAP with the code. All right. Now let me just open edge service application.java file so that I can find it here, right? Now, in order to enable fiend, Hystrix, and registration with the Edureka server, add the appropriate annotation. So what are the proper annotations? We have enable fiend clients, we have enabled circuit breaker, we have discovery client, Zool proxy, and Spring Boot application, obviously, right? So these are the annotations that we are going to use. And after that, let me explain you the code. Although it's pretty simple, guys, people who know Java will find it really easy to understand. So this is again the main class which Java will basically execute the first in my application, right? Then I have a couple of getters and setter methods defined here. I have an API adapter that will return the array list of our items. And finally, you can see the public collection item, good item, that you can see it in the end. Yeah, this is basically for collecting items and adding it into a list. Finally, this private boolean is great item. This will return true and false if the item is not available for a particular brand. All right, so it's pretty easy, guys. Now over here, I've created a DTO. Now let me just take you through the code once more. So if you notice here, I've already created a DTO, an item DTO, which means data transfer object in this same file. And the Lombox @data will generate two string methods, the getters and setters, the appropriate constructors. All right, then I've created an item client interface. So if you scroll down, you can see that we have an item client interface. So we can see that we have an item client interface that uses fiend to communicate to the item catalog service. So we have talked about item catalog service. So this item client interface will use fiend to communicate with the item catalog service, right? Then we have a REST controller below the item client. So over here we have the REST controller that will filter out less than top brands and shows a top brands endpoint. So slash top brand endpoint. So it will filter out the brands, right? It will add a filter to all the brands that we have in order to get the top brands, right? So that's what the REST controller will do. Now what I'm going to do, I'm going to start this service for you. So I've configured this service at port 8089. So let me just quickly go ahead and run this for you. I'm going to first click on run as Maven clean. So I'm going to quickly run this as a Spring Boot app and let us see what happens. All right, so let me just quickly open the Eureka server, right? And I'll just refresh this and you'll see that there are 2 instances currently registered with Eureka, right? So you can see that there are 2 instances currently registered with Eureka. Now let me just quickly go to a particular port, that is 8089. So I'll just type in here localhost 8089 slash top hyphen brands. And here we go. So we have got the top brands. So we have Lining, Puma, Bad Boys, and Air Jordan, right? Now what I'll do, I'll just quickly shut down the item catalog service application. For that, let me go back and I'm going to shut down the item catalog application. So this is what we have done in this particular use case. Now, if we shut down the item catalog service application, you'll get a 500 internal server error.
So what exactly is REST? Well, REST is the abbreviation for Representational State Transfer. RESTful web services are built to work best on the web. So did you get an idea what REST is? Let me define it for you. REST is an architectural style that specifies constraints such as uniform interface that, if applied to a web service, induce desirable properties such as performance, scalability, and modifiability. So this means that REST is a set of constraints that you need to avail, and once a service avails to these constraints, it is called a RESTful service. Coming to the REST architectural style, data and functionality are considered resources and are accessed using uniform resource identifiers. The resources are then acted upon by a simple set of well-defined operations. The REST architectural style constrains an architecture to a client-server architecture and is designed to use a stateless communication protocol, typically HTTP. In the REST architecture style, clients and servers exchange representations of resources by using a standardized interface and protocols. So, at the end, you can understand that the REST APIs communicate between the clients and the databases. So what exactly are these REST constraints? Well, the first one is the client server. This means that you should have a client and a server. That is, there should be a service provider and a service consumer. The next one is that you should have a uniformed interface. So you should know the functionalities of the application, you should know the resources required, and then you have to decide on how to expose them out. The other things are the services should be stateless, and also they should be cacheable. That means that the values returned should be stored in cache. And the last constraint that I would like to mention is that it should be a layered architecture. So basically, client should not assume to get a direct connection to the server. So now that you know the REST constraints, let's deep dive into what are the principles that encourage RESTful applications to be simple, lightweight, and fast. RESTful web service exposes a set of resources that identifies the targets of interaction with its clients. Resources are identified by URIs, which provide a global addressing space for resource and service discovery. The second thing is that resources are manipulated using a fixed set of create, read, update, and delete operations. So the put creates a new resource, which can be then deleted by using the delete. Get retrieves the current state of a resource in some representation, and post transfers a new state onto a resource. Resources are decoupled from the representation so that their content can be accessed in variety of formats such as HTML, XML, plain text, PDF, JPEG, JSON, and others. So, metadata about the resource is available and used, for example, to control caching, detect transmission errors, negotiate the appropriate representation format, and perform authentication or access control. The final principle that I would like to tell here is that every interaction with a resource is stateless. That is, request messages are self-contained. So, stateful interactions are based upon the concept of explicit state transfer. Several techniques exist to exchange states such as URI rewriting, cookies, and hidden form fields. State can be embedded in response messages to point to valid future states of interaction. So now that you know what is REST and its principles, how do we set up RESTful services for Spring Boot application? Well, there are 3 steps that we will follow. First, we will set up a simple Spring Boot project using embedded Tomcat that is in the Eclipse IDE. Then we will add a GET service to it. After adding a get service, we will learn how to handle the post service. So let's get started with it. Now, let's look into the project. We will use the concepts of customers ordering various products. So we will start by creating a get service to return what are the products a customer has ordered. Then we will also create another get service to retrieve the orders, that is the details of the specific order for a customer. So basically what I'm trying to do here is that I'm trying to get the details of a customer going for a particular product. So is that clear to everybody? Okay, I've got a yes. After that, I will also create a post service to register a customer for a product. So let's get started now. So let me just open my Eclipse IDE. So before getting into the project structure, let me show you how to create a simple Maven project. For that, you just have to go to File, you have to go to New and choose Maven Project. In the window that opens up, you have to choose Create a Simple Project and click Next. After that, you have to fill the following such as the group ID, artifact ID, name, description for your project, and then click on Finish. This will create your Maven project. So now that all of you know how to create your own projects, coming back to the project that I've already created, let me take you through the project structure of this project. So let me just open all the files. Okay. Now, let's start with the customer controller.java file. Well, this is the file which exposes the service methods such as get, post, put. Okay, so Sonia just asked me a question if I can just tell you guys what do these methods get, post, put do. Well, get does not update anything. It just gives the same results in multiple calls. Coming to post, post creates a new resource. Ideally, it returns a JSON file with a link to newly created resource. I'll explain you in detail in the video. Now, to update a known resource, you have to use the put service. So Sonia, is that clear to you? Okay, that's great. Now, continuing with the project structure, the product.java, the customer.java, and the customer service.java is the main business logic for the application we're trying to implement. So, I would show you how does the customer service exposes a couple of methods that are consumed from the REST controller. Coming to the customer controller it.java, it is basically for the integration test for REST services, and customer controller test.java is for the unit test for the REST services. And the main file here is customer service application.java, which is the launcher of the Spring Boot application. Lastly, you can see a POM file which houses all the dependencies you need to build for this project. So in this project, I'm using Spring Boot Starter Web. Okay, now that all of you are familiar with the project structure, let me get you guys into the business service for our application. As all of us know that a single application has various layers such as web, database, and business. All these layers have their own specific responsibilities that you can understand by the name. So now, let me open the customer service.java file. Well, so as all of us know that applications need data, instead of talking to a real database, I'll be using an array list, which is kind of a memory data source. So now, let me explain you the business logic on which I've built this application. Well, in today's world, as all of us do online shopping, you can very well understand that a customer can order multiple products. So, a product must have an ID, name, description. Similarly, a customer has an ID, name, description, and the list of products he or she has ordered. So this customer service.java file is basically exposing the methods. Let me brief you a little bit about the methods. So let me just scroll down. So basically, this retrieve all customers method retrieves the details of the customers. The public customer retrieve customer for a specific ID retrieves a specific customer details. This particular method retrieves all the products a customer has bought. Scrolling down. Okay, so this method retrieves details for a specific product a customer has bought. And finally, if a product has to be added to an existing customer, then this method is required. So well, these are the methods that we have. We also have some entities such as product.java and customer.java. So when I open this product.java file, I can see that the product is nothing but a simple object which has ID, name, and description. Coming to the second entity, customer is also an object which has ID, name, description, and also customer has a list of products he or she has bought. Coming back to this customer service file, all it does is it initializes the list of products. Let me just explain you the code now. So we start by using a simple static array list to store our data to keep it simple. So basically, we're storing all the list of products here. we are creating this application for 5 simple products and 2 customers buying those products. So we have product 1, 2, 3, 4, 5 and Payal and Neha buying those products. Other than that, we also have some few important methods that I told you previously. So let me just scroll it down for you. So we have a method to retrieve all the customers, to retrieve a specific customer for a product, to retrieve all the products that we have, and also to add products. So let me just tell you that all of these are very simple methods that we have created for our service. Now question comes, why have we created these methods? Well, the answer to this question is that we just want to use these methods from the controller. So now that we have our business logic ready, which is very important to us, is everybody clear with it? Okay, I've got a yes from most of you. That's great. So now coming to the main concept, how and where should we add our get service? So to add a get service, you just need to add @REST controller annotation, which is used to expose the REST services. So let me just open the controller file and show you. Okay, so this controller file will expose our REST services as this annotation is included here. So now, if you scroll down this file, you can see a couple of get methods. Well, let me tell you the meaning of all these methods. Look at the first method, which says customers, customer ID, products. So basically, /customers is the path we are using and the one in the flower bracket, that is the customer ID, is the path variable. So you can see that the path variable is mapped to the customer ID. So if I say, suppose customers/customer1, then I'm talking about customer 1 and want to get the list of products that customer 1 has ordered. Similarly, if you go to the second method, that is the customers, customer ID, products, and product ID, you can see that this method is used to retrieve a specific product for a specific customer. One interesting fact that I would like to tell you is that we have used the annotation @autowired. What does it mean? Why have we used? Well, in detail, you can refer to my previous video on Spring Boot tutorial, but let me just brief you a little bit about it. Well, @autowired annotation is used to autowire in the customer service. So now, if you just want to check whether the service is working or not, let's just launch this application. So let me just right click on this project, go to Run As, and choose Spring Boot app. Well, at the end of the console, you can see that Tomcat has started on port number 8080 and the customer service application has started. So now, to check if your application is working or not, open the browser and type localhost:8080/customers. Suppose if you want to check for customer 1, give in the parameter as customer 1 and map it to products. Okay, so on the screen, you can see the details of products that customer 1 has bought. So have you all just thought, how are we getting the output as JSON file when we just listed the data as a list? Well, this happens because of something known as message converters. So Spring Boot has this thing called autoconfigure through which it configures many message converters. So message converters basically look at the request and identify what exactly client is looking for. So if a client is looking for JSON file, then the message converter would convert this Java object product to a JSON file. Now, let me just tell you that the message converter is auto-registered with the Spring Boot. Okay, so the post method that I mentioned in the starting of the video, well, I told you that we use it to create a new resource. So just in case if I have to create a new resource for this application, I'm going to post map and map the URL to it. So what does this post mapping do? So post mapping would be to expose this as a post request and path variable is mapped to it. Now, one more thing that you can see here is the request body product new product. So whatever product you would put in the request body would be automatically bound to here. So when you execute the request, we would put the details of the product in the body of the request, and then the request gets bound to the request body. Once the product is found, the location of the product is printed. But if the product is not found, then it returns null.
Microservices security, let's understand the problems faced in microservices. Well, the problems faced in microservices are as you can see on my screen. Starting with the first problem, consider a scenario where a user needs to log in to access a resource. Now in microservice architecture, the user login details have to be saved in such a manner that the user is not asked for verification each and every time he or she tries to access that particular resource, right? Now this creates a problem as user details might not be secure and also could be accessed by the third parties. Now, obviously, guys, to anybody, user credentials are the most important credentials which have to be secured, right? Now, in a scenario where a client is logging into an application to access a resource, the application gets the complete credentials of the user. Now, if the credentials are not secured by those services, then that's definitely a problem because anybody can exploit it. So that is one problem that I clearly see. Problem number 2 is basically, I would say, when a client sends a request, then the client details need to be verified and also the permissions given to the client needs to be checked, right? So when you use microservices, it may happen that, for each and every service, you have to authenticate and authorize the client. So authenticate is basically to check what permissions are given to you, and authorize the client is basically to check who are you, right? So basically the user credentials are checked. Now to do this, developers might use the same code for each and every service, right? So what I mean by that is, when a client is trying to access few data from different services, it may happen that, the client details have to be checked to make sure if the data has to be sent to that person or not, right? Now to check that, maybe a specific code is used in all these services for a specific application. Like service A, B, C, D, E can all use the same code to check the authenticity of the client. But don't you think relying on a specific code reduces the flexibility of microservices? Well, obviously that's a yes, right? So this is one of the major problems also I see in the microservice architecture, that the complete application having various services is based on a single code base. And let's say you build an application now with that particular code in all the services to check the authenticity of the client. But let's say after 10 years, that particular code doesn't work. Now you have to change the code for all these services, and in the same time you also have to make sure that nobody is exploiting the data from the services, because there will be no security layer then, right? So this is one major problem that I see that that has to be catered. So the next problem that is very prominent in this particular architecture is basically the security of each individual microservice. Now what I mean by that is, basically in this architecture, all the microservices communicate with each other simultaneously in addition to the third-party applications, right? So when a client logs in from a third-party application, you have to make sure that the client does not get the access to the data of microservices in a way that he or she might exploit them, right? So it obviously makes sense because he's logging from a third-party application. Now maybe that particular application is not that secure. So maybe instead of the client, the third-party application is basically trying to access the data. So we have to make sure that the data is secure, and not every application is given an access to the data in the services, right? So guys, these are few problems that I see very much prominent in microservice architecture. Well, there could be a lot other problems based on security of microservices. So these are few problems that I thought would be very prominent, right? Now, obviously, seeing so many problems, we have to figure out a way to secure our services, right? Now, to secure our services, all we can do is we can put up security layers, firewalls, and use some methods to make sure our services are secure, right? So on that note, next in this session, let's see the best practices for microservices security. Well, the best practices for microservices security are a lot. I would not say the ones that I mentioned are the only ones. There are a lot of ways through which you can secure your services. But I would say these are few methods, through which you can start at least securing your services. Or maybe you can figure out a way to at least make sure your data is secured, right? So let's start with the first one, that is defense in depth mechanism. Now, as microservices are known to adopt any mechanism on a granular level, you can apply the defense in depth mechanism to make sure that the services are more secure. Now what I mean by that is, the defense in depth mechanism is basically a technique through which you can apply layers of security countermeasures to protect the sensitive services. So as a developer, you just have to identify the services with the most sensitive information and then apply a number of security layers to protect them. So in this way, you can make sure that any potential attacker cannot crack the security on a single go, and has to go forward and try to crack the other layers in the defense mechanism, right? So basically, if you say, service B is the most sensitive service, which has, a lot of information, which has to be secured, right? So what you can do is you can basically have layers of security, and maybe if some attacker cracks the security of the first layer, he or she has to still go and crack the other layers. But by that time, you'll definitely understand that, there's some problem in security happening, and then you'll again secure your services, right? Also, since in a microservice architecture, you can implement different layers of security on different services, an attacker who is successful in exploiting a particular service might not be able to crack the defense mechanism of the other services. For example, let's say you have service A and service B, And let's say, you have few layers of security in service A and few different layers of security on service B. Now, maybe an attacker who has attacked service A and has cracked the security might not be able to do the same for service B, right? So that was about the defense in depth mechanism, guys. Let's take a look at the second best practice, that is usage of tokens and API gateway. Now, often when you open an application, you see a dialog box saying, accept the license agreement and permission for cookies, right? Now, what does this message signify? Well, once you accept it, your user credentials will be stored and a session will be created. Now, the next time you go on the same page, what will happen is that, the complete page will not be loaded from the server, but will be loaded from the cache memory, right? So I hope that's clear. So for example, let's say, you open bookmyshow.com. So now the first time that you open and then you accept the license agreements and the cookie permissions, what will happen is that your user credentials will be stored and a session will be created. Now the next time again, maybe sometime later, you open Book My Show again, that particular page will be retrieved from the cache memory rather than the service itself, right? Now, before this concept came into the picture, sessions were stored on a server side centrally. Now, this was one of the major problems, as storing the session centrally was being a barrier to horizontally scaling the application. So to overcome that, what people started doing is basically everybody started using tokens and API gateways to secure the services, right? So what would happen with tokens is that, tokens would be used to record the user credentials. So basically you can understand that, tokens are used to store the user credentials. So these tokens are used to easily identify the user and are stored in the form of cookies. Now, each time a client requests a web page, the request is forwarded to the server, and then the server determines whether the user has access to the requested resource or not, right? Now, the main problem which is prominent in tokens is that the user information is stored, right? So the data of the tokens needs to be encrypted to avoid any other exploitation from third-party resources. And I would say JWT, or most commonly known as JSON Web Format, is an open standard which defines the token format to provide libraries for various languages and also encrypt the user details, right? So guys, just to avoid storing sessions centrally, what people started using is tokens. Now, tokens are used to store the user credentials, and since the user credentials are stored in the tokens, tokens have to be encrypted themselves. So you can go forward and use JWT to encrypt the respective tokens, right? Coming to API gateways, API gateways add as an extra element to secure the services through token authentication. So the API gateway acts as an entry point to all the client requests and efficiently hides the microservices from the client. So the client basically has no direct access to the services, and thus in that way, no client can exploit any of these microservices, right? So what happens is that you have a client and then you have API gateway. Now API gateway will communicate with all the APIs present in the microservices, right? So basically over here, if you visualize, the client has no direct access to the services. Instead, it's just the API gateway, and it's completely the responsibility of the API gateway to forward the request to the respective microservice. So guys, that was about tokens and API gateway. Let's move forward with the third best practice, that is distributed tracing and session management. Now, talking about distributed tracing, all of you might be observing that, while you use microservices, you have to monitor all these services continuously, right? But when you have to monitor a humongous amount of services simultaneously, that definitely becomes a problem, right? For example, if you just have to monitor 5 services, then maybe that's an easy task. But in a scenario, maybe if you have to monitor 50 or 100 tasks simultaneously and 24/7, then that's a problem, right? Now, to avoid such challenges, what you can do is you can use the method of distributed tracing. So distributed tracing is basically a method to pinpoint the failures and identify the reason behind it. Not only this, but you can also identify the place at which the failure is happening. So basically with that, you can easily track down which microservice is facing a security issue. Right? For example, let's say, you have 5 services and then there's some error happening at service B, right? So you can directly go and pinpoint that it is because of service B, there's some failure, and maybe then you can directly go and figure out that, there's some security issue at service B rather than to check all the services and the complete application, right? So that's what distributed tracing helps you guys. It makes you identify where is the failure happening, why is the failure happening, and then which service is it affecting. Moving on to session management. Session management is an important parameter that you have to consider while securing microservices. Now what happens is that a session is basically created whenever a user comes onto the application. So what you can do is you can handle these sessions in many ways. I could figure out 3 ways. The first way is basically you can store the session data of a single user in a specific server. What I mean by that is the session data of user A is maybe stored on server A. The session data of user B is basically stored on server B, and session data of user C is basically stored on server C, right? So in that way, you can make sure that if there's some exploitation of services, then you can track down which user is doing it directly without having to figure out what is happening and all. You can directly track down that, maybe user A is exploiting or user B or user C, right? But the only problem over here that I see is that, the system is completely based on load balancing between the services, and it meets only horizontal scaling rather than the vertical scaling. So for small applications, which let's say, have 3 to 4 services, maybe this kind of system can be used. But if you want to use this scenario for a large application, then I think that will create a problem, right? Coming to the second way, well, what you can do is the complete session data can be stored on a single instance. Then what can happen is that, the data can be synchronized through the network and the requested responses can be generated. And you can also make sure that, the data doesn't go anywhere, right? So what happens is that, you have a single instance, and then through network, the data is completely circulated between services and the client. Now, the problem, if you think over here, is basically the exhaustion of the network resources, right? For example, let's say you need a data from 10 services, right? And all the data is completely stored on a single instance. Now, all these services have to communicate with that particular instance, get the requested response, and then finally send back to client, right? Now, this is a little bit problematic when you have large services again, but I would say for small services, you can go forward, right? Now, finally, coming to the third method, what you can do is you can make sure that the user data can be obtained from the shared session storage so as to ensure that all the services can read the same session data. So what I mean by that is if you have 5 services and the 5 services need the user data, then the user data is obtained from a shared session storage through which the data can be retrieved, right? But since the data is retrieved from a shared storage, you need to make sure that you have some security mechanism to access the data in a secured way. So basically, you have to make sure that you add another security layer, maybe by using the defense in depth mechanism to make sure that the data is encrypted with the help of tokens, or maybe you have a specific firewall that not all of them can access the data and no third-party applications can access, and only a few admins can access, right? So you can use it the way that you want. So guys, that was about distributed tracing and session management. Let's move forward with the next practice, that is first session and mutual SSL. Now, the idea of first session is really simple, guys. What you can do is basically when the users log in for the first time into the application, then they can access all the service in the application, right? So what you can do is whenever the user logins for the first time, you can store his or her details in an encrypted format in a secured way so that they don't have to keep verifying their credentials each and every time they're trying to access different servers. For example, if you have 10 services and maybe the user needs to log into all the 10 services, what you can do is you can have an initial login. And when the user logs in for the first time, maybe he or she gets access to all these services. But the only problem over here is that, you have to make sure that, the user who is trying to log in is a client himself. And maybe he or she is not an attacker and is not trying to exploit the resources, right? Coming to mutual SSL, applications often face traffic from users, third parties, and also microservices communicating with each other, right? But since these services are accessed by the third parties, there's always a risk of attacks. Now, the solution to such scenarios is by using mutual SSL or mutual authentication between microservices. With this, the data transferred between the services will be encrypted. And the only problem with this method is that, when the number of microservices increases, then each and every service will have its own TLS certificate. It will be very tough for the developers to update the certificates. Else, if I would say the developers are ready to update the certificate and maybe they're not scaling the number of services, then I think they can go forward with this particular method. As each particular service will have its own TLS certificate, and that particular certificate will define which microservice has what access and which data can be retrieved from each of these services, right? So mutual SSL sounds like a good option, guys. I think you should go forward and all. But the only thing is that when you're scaling your service, you have to make sure that you have to update all these TLS certificates. On that note, let's move forward with the final practice, that is the third-party application access. Now, all of us access applications which are third-party applications, right? So the third-party applications basically use an API token generated by the user in the application to access the required resources. So the third-party applications can access that particular user's data and not the other user credentials. Well, this was with respect to a single user. But what if the applications need to access data from multiple users? How do you think such request is accommodated? Well, I think the solution to this is by using auth. So when you use auth, the application prompts the user to authorize the third-party applications to use the required information and generate a token for it. So generally what happens is that an authorization code is used to request a token to make sure that the user's callback URL is not stolen, right? So in this way, the user or the client communicates with the authorization server while mentioning the access token, and also the authorization server authorizes the client to prevent others from forging the client's identity. So when you use microservices with auth, guys, the services act as a client in the auth architecture to simplify the security issues, right? So I would say, guys, all these methods that that I've explained you are one of the best practices that I've observed to secure your microservices. But if you ask my personal opinion, I think I would always go for auth with a collaboration of JWT, that is basically generating client tokens, and always follow the defense in depth mechanism to make sure that there are a number of security layers to my services so that the data stored in my services is completely secure, right? So if you're someone who is aspiring to build an application based on microservices, then remember that the security of the services is one important factor which you need to be cautious about, right?
Now, before we go into details about SOA and microservices, let's see what is a monolithic application and how that functions. First of all, you can think of a monolithic application as a container which is basically hosting a number of software components, right? There can be a number of software components as part of your software application. And if they are all hosted together and delivered together, then that's called a monolithic application. Now, there are various challenges with any software application which is implementing the monolithic architecture. First of all, they are not flexible. Okay, monolithic applications, they cannot be built using different technologies. That's the problem. The second challenge is that they are unreliable. Even if one feature of the system does not work, then the entire system will not work. The third challenge is that these monolithic applications are not scalable. They cannot be easily scaled, and even if the application needs to be updated, then the complete system has to be rebuilt. The next problem is that with these monolithic applications, they block continuous development. All the features cannot be built and deployed at the same time. They will have to be done separately. The next challenge with monolithic applications is that the development is very slow. They take a lot of time to be built, since each and every time every feature has to be built one after the other. And most of all, the monolithic applications are not fit for complex architecture, because of course you cannot use different technologies. You are very limited and very constrained, right? So that is the challenge with monolithic applications. So now let's go on to SOA, which is nothing but service oriented architecture. Now with SOA, these services or features, they are broken down, right? The entire software application is not built as one, but the different features and the different services are broken down into smaller components, right? So that's why it's called coarse-grained architecture. And over here, if we have, let's say, one software application inside which it provides, and if it provides like 5 features or 4 features, then all those 4 features are delivered by 4 different services. And that is what you can see over here, right? There are 4 different services. And each of these services would have multiple tasks inside them. And these smaller tasks are together delivered as one particular feature. And the whole software application comprises of a number of these features. But with microservices, it's a little more different. Now, these features or services are further broken down into task level services. So here it was feature level services, whereas the services here, they are task level. Each and every task in a particular feature, that was broken down, and that's why you have multiple tasks and multiple services in a microservice architecture. And that is why this is called fine-grained architecture. So that is what the differences are between these three on a high level. Now, before I go further and confuse you people, let me just go into more details about the differences between SOA and microservices. You can think of the difference between SOA and microservices with the help of these images. So SOA is like an orchestra. Similar to you having multiple performers, you will have multiple services, but each of these performers will be controlled by one particular director. And similarly in SOA, even though you have multiple services, these services will be interacting with one another, and then they will be delivered as one particular software application. But whereas in case of a microservice, there are multiple, or let's say there are independent performers, but these independent performers are not controlled by any director. So they work separately, and they work in silos. So that is the difference. So I hope you can understand the difference between the two from these images, right? Even though they work together, they are controlled by one particular director. And that's why this is called a centrally governed architecture. And whereas microservices, you do not have a centrally governed architecture, and that's why it's called a decentralized governing architecture. So let me go forward and talk about the difference between these two, which is nothing but microservice and SOA, with respect to certain parameters. Let's look at the difference between them with respect to architecture and coordination. So first of all, in SOA, there are 4 different types of services. First is business service, the next is enterprise service, then we have application service, and then we have infrastructure service. So these 4 service types together form your SOA, and they together deliver your software application. Now, what are these different services and what do they do? Let's see that. First is business service, right? So your business service is the one that's going to be performing your core business operations. And it can be either represented by XML or by web service definition language. And then we have enterprise service. The enterprise service is that service which implements the functionality defined by your business service. And the enterprise service does it with the help of the application service and the infrastructure service. Now moving on, we have application service. The application service is the actual core application or the core functionality of that feature. And these application services can be either invoked directly or they can be invoked through a user interface. And now we have infrastructure service. The infrastructure service refers to those non-business or those non-technical operations such as auditing, scaling, or security, and all these things. Those are the different services in a SOA. But in case of microservices architecture, you do not have these many types of services. You just have a functional service and you have an infrastructure service. The functional service is basically the combination of a business service, an enterprise service, and an application service. Now, a functional service is a fine-grained service. So basically, if your business logic or your business operations requires a particular feature to work, then the task that is related to exactly that particular feature, that is performed by the functional service. And besides the functional service, we have an infrastructure service. And the infrastructure service over here is very similar to the infrastructure service that is there in SOA. It does all the non-business or the non-technical operations such as your security, auditing, and logging. Okay, so that is the difference with respect to architecture and coordination. So now moving on to the next slide, we have heterogeneous interoperability. Now what this means is any software application need not be developed on the same programming language. Now in your main software application, you might have smaller applications, right? And each of those smaller applications could be written on Java, or it could be written on .NET, or it could be written on C# or Python or anything. Now, when it's written in different programming languages, it's tough for them to interact with one another. And if you want the different services to communicate with one another, then you would have to bring a particular platform, right? So that's where you have this messaging middleware. So in case of SOA, there is something called as a messaging middleware, which acts as the communication point or the interaction point between the different applications which are in a different language. So you can see that this application is on either C# or .NET, and this is on Elastic Java Beans, right? Similarly, here it's C++ and here it's Java. So, and all of these communications, they go to this one particular messaging middleware. But in case of microservices, we do not have any broker here. The communication happens directly between application to application, even if they are in different programming languages, even if they are structurally different, and even if they are built in different grounds. So look at this. If you have a C# or a .NET application which is communicating with a Java application, but then how does it happen? It happens with the help of a REST API. There is direct communication between these two services. And similarly, if you have another Java application which wants to communicate with another Java application, the communication would take place with the help of REST API. And similarly, Java to C# or .NET would again take place with the help of a REST API. So there is no broker here or middleman, which is a messaging middleware. The communication is directly to the other application. Then comes service granularity. If you can remember, I earlier told that in microservices, you do not have the software delivered as a whole, right? It is broken down into smaller features. And if you're basically performing an operation which involves multiple applications or multiple services, then those services are called by one another when it's needed. So as an end user, as a consumer, you might be performing one operation, okay? So that one operation would not be calling all the different services. It would call one service, and this service, when it needs to interact with the second service, this would make the call to service 2. And similarly, your service 2, when needed, it would call service number 3. And similarly, once the service request is made, the service response is also given to the one that's invoking the request. Now the catch here is each and every service request and service response takes 100 milliseconds. Okay, so let's assume it takes this much time, the API calls. And this is in case of microservices. So in the microservice architecture, when each call takes 100 milliseconds, in total, for this service to get successfully returned, it would take 600 milliseconds. Now that's an awful lot of time for an API call to complete successfully, right? For an API call to be made successfully and to be returned. And this is where it is different from an SOA. So in case of an SOA, the service consumer would again be calling, would be performing one particular operation. And what happens here is this operation would be calling the different services all at the same time. So the operation over here would be calling the service number 1, service number 2, and service number 3. It should be encompassed all together. So one particular call would be made to the service, and all 3 would be serviced at the same time. And by this, you would be saving time because all the 3 requests and responses would be made simultaneously. So you would be saving a good 400 milliseconds over here. So that is the difference in service granularity between SOA and microservices. So the next difference we are going to see is with respect to component sharing. This is very similar to the previous slide again, right? Because then it would be the same order service which would be interacting with your different smaller applications, each for customer management and for warehouse management and for order fulfillment. And the data again would be stored in different databases. But there again is the difference in microservices, because in the microservices architecture, for each and every application, so for customer management, we have a separate order service, and that order service would be accessing its own database. For warehouse management, you have a separate order service, which would be accessing a different database. And then for order fulfillment, which is again a different application, this would be using a different order service, and this order service would be using a different database from where it would be accessing data, right? So that's how there's a difference in even component sharing between these two architectures. And then we have the next difference between them, and that is the middleware versus API layer. This we also spoke about earlier, right? Your SOA uses middleware for communication, and your microservices uses an API layer for communication. So that is about the differences between SOA and microservices. Now let's go ahead and look at the differences between the two by understanding with an example of a shopping cart. So every e-commerce portal will have a shopping cart, right? Where you can add your products to the cart and then you can check out later. So for adding an item, for removing an item, for checking what is the tax, for checking the total bill amount, for all those things, you have a shopping cart application. And then finally, we have another application, which is the main application, which gives details about the product. So it will give us details about the product name, what is the product ID, what is the product rate, how many quantities are present, and all different other options, right? What color the product is and all these things. Now, these are 3 different applications, and when they work together, you get the complete software application, right? Now, each of these applications would have smaller tasks. A shopping cart application, like I told you before, it would have an add or remove functionality where you can add a product to your cart, you can remove a product from your cart, you can check what is the bill in your cart, you can check out what is the tax that is there, and all these things. Similarly, if you talk about a product catalog, you have other tasks, right? So all these tasks together form one particular application service in case of a SOA shopping application. But in case of microservices shopping application, each of the different tasks that these services provide, those tasks are broken down into smaller fine-grained services. So here we have feature level services where shopping cart is one feature, product catalog is one feature, and user account application is one more feature. But in case of microservices, we have a separate billing service. For shipping, we have a shipping options service. We have a tax calculation service, right? So the different tasks in this particular feature, it's broken down. Similarly, for product catalog application, we have different task level breakdown, such as display product service. We have an update display service. We have user default service and many more. Similar for user account application, right? We have a send email service and many more. Now that you've understood that microservices is all about breaking a particular feature or a feature level service into task level services, So let's see how microservices shopping application is different. So first, let's take the case of where a microservice shopping application is better. So here we'll have certain features which are common to multiple applications, right? So we have something like a display image service. So it's a smaller task level service over here, but the image of the product being displayed might be common across all the three applications. It might be present in the shopping cart also, and the image of the product might be present in the user account application also, with showing which are the products which the particular user bought. And then you might have the product, you might have the image of the product in the product catalog application also. So in this case, if there's a change in the image dimensions or in the license of the image or anything with respect to the product's image, then the code of course would be similar in all the three applications, right? The code may be similar, but the code has to be changed everywhere, right? And when you change the code, when you rework, then it causes a lot of problem again. Now when you change the code here, you're changing the functionality, and that might cause this particular application to behave abnormally. It might have bugs, or the application might cause failure. And similarly, if you change the code over here, then even this might throw errors and you might have bugs. Similarly to this particular application also. So if you want to avoid all those things, you have to test each of these applications separately after changing the code and after updating the required details. And after testing it, you will have to deploy each of these applications, and you have to deploy them separately. Now, all these things is time consuming, right? So it is the same change that you're doing across all the different parts of your application. But even though you're doing it everywhere, even though you're doing something similar, you will have to test and deploy each of them. And sometimes you might have errors in only one particular application and not everywhere. So these are all time consuming tasks. But if it's in case of a microservices shopping application, you would not have this problem, because all the different tasks over here, they are provided as a service. If you want to change the way the product's image looks, then you will have to change only this particular application, right? So by only changing this service, your job will be done. You do not have to worry about the other services, and you do not have to change anything over there. So the main change you will have to be doing will be restricted to only this particular service. So you save time and you save effort over here in case of microservices shopping application. Now this was a use case where the microservices shopping application was better, but then there are also times when an SOA shopping application is better for you. So this was a classic use case of where a microservice shopping application is a best fit. But let's see a use case where an SOA type of a shopping application and the SOA architecture comes out better. And that example is when your product is not actually that big. So in this case, yeah, you have a lot of functionalities, you have a lot of features and tasks. So just consider the example of a very simple software application which needs three primary functionalities. One which has like a shopping cart, which into where you can add your items, and then you have another user account application where you will have the user profile, and then you will have a product information application, right? So over here, all these different applications will not have too many sub-level features or sub-level applications. They are very straightforward. They are very simple. In this case, if you're implementing microservices architecture, then you will have to go through a lot of trouble, which can simply be avoided because your application is in itself very simple. You have to just create one website where you can have one website in which you have a cart wherein you can add your products which you want to buy. Then when you're checking out, you can have the user information displayed, and then you have details about the product, which is a separate application. So in this case, it could just be these three different services. So that is the difference between an SOA. So I think by now you understand that neither of them is better than the other, right? So there are times when microservices is preferred, and there are times when SOA is preferred. And you cannot hardcode it by saying that one is better than the other.
Now, if you consider an e-commerce application, what do you think are the main three functionalities of it? For example, let's say you're using Amazon. What all do you see? You're a customer, right? You see all the products on Amazon, and then you put your products into the cart, and finally you order those products, right? That is basically the simple workflow if you have to understand. Now, if you have to build this application using microservices, what you can do is you can have mainly three functionalities, that is the customer information, the products available in the cart, and all the products available on the website, right? Now, all these three functionalities can be put into different services. What I mean by that is you can have service A having customer information, service B having the products available in the cart, and service C having all the products available in the application, right? Now, when the customer goes forward and orders a particular product, you can have a composite microservice which will basically take data from all these three services and generate the output for the client, right? So I hope you've got an idea of what I'm talking about, right? Now, as I was telling you that, before microservices came into the picture, there was monolithic architecture. How do you think all these functionalities of the application were stored in this kind of architecture? Well, it's really simple. What would happen would be all these three services, that is the customer service, the product service, and the cart service, would be residing in a single area, and then there would be a data access layer through which you can access the data, right? So as you can see on my screen, you have a client browser through which the client requests for the information. So as soon as the client would request for the information on the application, the request would be passed to this particular area where all the functionalities are present, and the data would be retrieved from the data access layer and the database. So if I have to just define monolithic architecture for you, then it's really simple, guys. Monolithic architecture is an architectural style in which all the functionalities or the required components would be inside one single block, right? So I hope that particular part is clear. So I hope that you've understood what was monolithic architecture and what are microservices. On that note, let's get into the second topic for today's session, that is, what are APIs? What do you think APIs are? Obviously, everybody has heard of this term API, right? So you can basically understand APIs as a point of contact through which all the services communicate with each other to process the client request and send the response, right? So for example, let's say, you've sent a client request. Let's say on Amazon, you've requested for a phone, right? So if you just type phone, what will happen is that, this particular request will be sent through APIs to the respective functionality or a feature, right? And that particular functionality or a feature will retrieve the requested data and then will send back the response to the client, right? So if you see you're a client, then there's particular functionality or a feature present in the application, and then in between both of you, there's API through which we can communicate, right? So I hope that point was clear. Now, while building and using these applications, what developers do is that, we basically use the CRUD operations. When I say CRUD operations, what I mean by that is we basically create a resource, read a resource, update a resource, and delete a resource. So APIs are generally developed by using the RESTful style, and these methods are nothing but the HTTP methods. Now, I'm sure you must have got confused when I said create a resource, read a resource, update a resource, and delete a resource. Well, guys, it's really simple to understand. For example, let's say, you're using Book My Show, and then you want to find out the details of a specific movie. So what you do is you send a client request. So when you send a client request, you're basically asking for the information, right? So what will happen is that, the information has to be read, and then the response has to be sent to the client. So that's basically reading a resource. Coming to creating, updating, and deleting, this is on basically the developer side where, they keep adding the information to the application, or maybe specific movies details are updated, or maybe the complete movie is deleted, right? So basically the information of the movie is deleted once it is out of the market, right? So that's how basically it works. Now, whenever we send a request, what happens is that we are basically sending an HTTP request, right? So for that, we use the HTTP methods, right? So next in this session, let's understand the different HTTP methods. So the HTTP methods are, as you can see on my screen, we basically have the post, get, put, and delete methods. So whenever you want to create a resource, you basically use the post method. Whenever you want to read a resource, you use the get method. Whenever you want to update a resource, you use the put method. And whenever you want to delete a resource, you use the delete method, right? So basically, guys, APIs use these methods to basically communicate between the client and the respective functionality or the feature of the application, right? Now, if you want to know more about HTTP methods and APIs, you can refer to my session on what is REST API. So on that note, this is all that you have to understand the differences between APIs and microservices, right? So now that I've told you, what are microservices and what are APIs, let's get into where are exactly APIs used in microservices. Now, when I was explaining APIs for you, I was always saying that, they're basically a middle person between the client and the respective feature or the functionality. Now, obviously, that particular feature or the functionality can go into a specific service, right? So let's say, we have a functionality of all the products present in the application. Now, that particular feature can be present in a specific service, right? So now when a client requests for all the products available in the application, the request can directly go to that particular service and the response can be generated back. So I hope that point is clear. So what you can do is basically the application that we took, the example that we took, we had a client browser, and in the monolithic architecture, the customer information, the product service, and the cart service, all these three services, basically all these three functionalities were residing in the same area. And then there was a common data access layer and then a common database, right? Now, when you break down this application, or maybe when you refactor this application into microservices, what you can do is you can have a specific microservice, and then you can have its own data access layer and database. And for each microservice, there's a separate API, right? So basically, the customer microservice will have a specific API, its data access layer and database. Similarly goes for the product microservice and the cart microservice. Now, it's not necessary that, there's single database for each and every microservice. It may also happen that, 2 or 3 microservices share a common database through which the data is retrieved, right? So basically, guys, if you have to understand where APIs are used in microservices, it's really simple. Each service will basically have its own API through which the services will communicate with the client, right? So for example, let's say, you're a client and then you're asking for your own information, your own customer details. What will happen is as soon as you send the request, basically the API gateway will decide to which service this particular request has to be sent. Now, since we want the customer details, this particular request will directly go to the customer microservice. And what will happen is that, the required data will be retrieved from the API. And then again, the API will send back the requested response to the client, right? So basically, that's all that you have to understand, guys, that, each service will have its own API. And then through that particular API, you can communicate with that particular service, right? Now, it's not necessary that, you need information from a single service, right? Even in that scenarios, what will happen is that, each microservice will generate the requested data and all of them together will send back the requested response to the client, right? So I hope that you've understood where are APIs used in microservices, right? Now let's move forward with the final topic for today's session, that is the differences between microservices and API. Now, in this tutorial on microservices versus API, I hope that, you've understood what are basically microservices and what are APIs, guys. These are completely two different things. Microservices is basically an architectural style through which you can build the applications in the form of small and autonomous services. Coming to APIs, APIs are a set of procedures and functions which allow the consumer to use the underlying service of an application, right? So basically, guys, this is the main difference between microservices and API. The microservices is basically an architecture through which you can build the application. And APIs is basically like a middle person between the client and the services through which you can establish communication between both of them, right? So I hope that point is clear. Also, from the example that I had explained you, I'm hoping that, it's clear to you that, APIs are a part of microservices and thus it helps these services communicating with each other. However, while communicating with the other services, each service can have its own CRUD operations to store the relevant data in the database. Not only this, but while performing the CRUD operations, APIs generally accept and return the parameters based on the request sent by the user. So for example, if the customer wants to know the order details, right? So maybe he must have ordered few items. What will happen is that, the product details will be fetched from the product service, the billing address and the contact details will be fetched from the customer service, and the product purchased will be fetched from the cart service, right? So basically, if you have to, generate a specific data, or maybe if you want a specific data, all these services can communicate within each other with the help of APIs and generate the requested response, right? So I hope it's clear to you guys. So guys, this was the basic differences between microservices and API. Microservice is basically a simple architectural style, and APIs are a set of procedures and functions which allow the consumer to use the underlying service of the application. So if you're someone who is aspiring to build an application using microservice architecture, I would always say that, make sure that, your APIs are working and then all the services are collaborated with the APIs in such a way that, no request is harmed and maybe all the client requests are satisfied with the requested response, right? So I would just say go forward and build applications using microservices.
So the first question is, what are microservices? Now think of it as an approach towards software development. What do I mean by this? What this approach does is it aims at having small autonomous services that focus towards a common business goal. Now, as you can see in this image, what we have is we have a number of business domains, and surrounding that are certain microservices. Now, each of these microservices, they focus at a particular business functionality only. That means if a particular business domain has, say, 20 functionalities, each of microservices would focus at one functionality only. For 20 microservices, 20 corresponding functionalities. So that is how you simplify an architecture. And this approach is called as microservices architecture. As we move further, we would be understanding a lot more points and concepts about microservices. So you would have a lot more clearer picture as to what a microservice exactly is. Meanwhile, you just bear with me so that we can move further and discuss the other questions as well. So what are the advantages of microservices architecture? Well, there are quite a few advantages, to be honest. These are some of the important ones which we have jotted down. The first one is independent development. Now, when you talk about microservices, you have to relate it to this point because we are talking about having an individual microservice for individual functionality. That means for each functionality, you can develop a separate service and you can manage it and control it totally. Apart from that, we also ensure independent deployment. That means if you have developed a single service, you can go ahead and deploy that service. You do not have to wait for the complete architecture or other services to be ready and up for deployment. Even if there is certain amount of change in a particular service, you have to make change only to that service and then deploy it again. You do not have to deploy the complete architecture here. Fault isolation. Now, if a particular microservice goes down, it does not affect the functioning of other services. Now, what do I mean by this? Say, for example, I have an architecture where I have some 20 applications or 20 services working parallelly. If one of the application fails, at times what happens is these applications are interdependent, as it is in the case of a monolithic architecture basically. If one of the system fails or one of the services fails, it takes the whole system down. Now, this is not true with microservices. If one service fails, it does not affect the functioning of other services in any possible way. Mixed technology stack. Now, what do I mean by this? Well, since you have different microservices and you have an independent approach towards development, you can go ahead and pick the technology that suits the need of that service. And accordingly, you can have a mixed technology stack for your complete architecture. Granular scaling. Now, this is an important point. Scaling can be a huge problem because again, you have to take into consideration the complete architecture. But since you're having small services, you can actually go ahead and scale those independently again. Now, these are some of the advantages which I just mentioned. So let us move further and take a look at the next question as well. What are the features of microservices? Well, the first feature is decoupling. That means your applications can be easily decoupled or rather separated to have individual functionality. And that means it assures easy development, maintenance, and deployment. Componentization. Now, this point is similar to the first point, but it is little different. What happens here is every microservice is treated as an individual component and it is responsible or manages all the intricacies as far as a particular service is concerned, and it focuses only on that. It is loosely coupled with other services. That is why each microservice can be thought of as a single component or a container. Business capabilities. Now, business capabilities can be focused much better because why? Since you are setting up smaller goals and you focus on individual functionalities, it becomes easier to go ahead and develop applications to meet these requirements as far as your business is concerned. Autonomy. What happens is your developers are now free because you are talking about small clusters of teams and they're free to go ahead and develop the applications. That means other teams and developers, they aren't interdependent on each other. This assures speedy development of software basically. Continuous delivery. Now, since you have so many features which we just discussed, this ensures that you have constant and frequent releases of softwares and a system can be continuously updated and basically modified as per the needs of a particular company or a particular business domain rather. Responsibility. What happens in this approach is every domain or every project is treated as a product. That means a team will take responsibility of that so-called product and they'll bring it to life, and it is their responsibility to build it, test it, and carry on with the whole life cycle. That means people are supposed to take in responsibility of the microservice that is there, and this helps in a much better architecture rather. Decentralized governance. Now, what happens is since you have individual applications, it is very important to have an independent approach towards the life cycles of each microservice. Since they are working independently, they should be managed independently as well. And this also brings in another concept into picture, which is decentralized data management. As we move further, we would be discussing that as well. Agility. Now what happens is, since you have a decentralized architecture, here you can easily go ahead and build applications and also discard them if they're not needed. So it gives you a lot of agility basically. So these were some of the features of microservices. Let us move further now. What are the characteristics of microservices? Now, first few questions might sound a little repetitive because these concepts are kind of interlinked. So we would be discussing quite a few concepts again and again. But as we move further, the breadth of questions or the type of questions would definitely vary, and we would be having much more newer topics to discuss. This question, on the other hand, might sound a little repetitive. So just bear with me. Let's quickly walk through it. And let me just try to give you some answer to this question in a little different perspective rather. So firstly, we have organized on business capabilities. Now, what do I mean by this? Basically, what happens is, since you have individual microservices, here what happens is you have an application that works on its own. You also have a database that corresponds to individual microservice. That means if you have 10 microservices, you'll have 10 individual databases that are corresponding or answering only to that particular microservice. So this gives you a complete decentralized structure. And this also means better organization because every microservice is very clear as to what it is supposed to do, and it has all the resources in that single container as to this is what is to be done and this is what we are focused on. And that is why this organization or better management comes into picture. Products are not projects. Now, what do I mean by this? Well, basically what happens is, suppose you have again say 10 microservices. Now you'll be having small clusters of team who would be responsible for building up this application and also maintaining it. Now what Amazon thinks is you should have a 2-pizza team basically. What do they mean by this? Well, they mean is you should have such small team that can survive on 2 pizzas, and they should also be able to go ahead and maintain the software. So every responsibility as far as a software and application is concerned, it is given to that size of a team, that is, that can survive on 2 pizzas. Now this ensures modularity. That is why when you talk about microservices, basically you're talking about products. When you talk about a team, they're focused on a particular functionality, and that functionality is not as a project for them, it is more of a product for them. Smart endpoints and dump pipes. Now basically this means that you have different applications and they're quite decentralized, and there has to be a way of communication basically. So you should have smart endpoints and good ways to integrate your applications with each other. Decentralized governance. We've already discussed this point, so I would just skip this point for now. Decentralized data management. We've also discussed this. That means you're free to have an individual approach where you have your own database, and your single database in your microservice is treated as an individual entity or a container rather. Infrastructure automation. Yes, this is an important point. Now, since you have so many microservices, it is important that there is proper automation. This ensures speedy development and also maintenance. Design for failure. Now, this is another important point. Now, your applications are such built that they do not hamper the progress of any other applications, even when they fail. But still, you need to have a mechanism that takes care of failure as well. So you have real-time monitoring and analysis here, which ensures that if an application goes down, the fastest possible action is taken so that that application also comes back to running, and also it does not hamper the working of any other applications in any possible way. So what are some of the best practices to design microservices? Now, it is pretty evident. You can just go ahead and read these points and you would understand what it means. Firstly, you need to have a separate data store for each microservice, which we have already discussed this point because we have a database which corresponds to particular microservice basically. Keep code at a similar level of maturity. Now, what do I mean by this? It means, yes, you have enough freedom to go ahead and build application the way you want to, but each of these applications are at a similar level of understanding. Now, when you talk about a similar level of understanding, you're talking about a similar level from a business domain perspective. And what this means is all the teams are on a similar page. Even though they're working on different things, they all are on a very same level when they're working. Separate build for each microservice. Yes, we've discussed this already. These microservices, they get deployed in containers. As we move further, we'll be understanding what containers are and what they do exactly. And it treats servers as stateless. This helps in better communication basically. What is a DDD? Now it stands for domain driven design. Again, it is an approach that actually helps you collaborate all the teams together, and it also helps you simplify the creation of complex applications. Now what this does is it focuses on core domain and core logic. At times, you let go of what is right for you. Rather, you focus only on the business domain. That means this is what the business domain needs, and this is what we would include in this architecture. This kind of an approach is called as domain-driven approach or a domain-driven design, basically. Now, what they do is they try to bring again every team on the very same page, and you'd be using something called as a ubiquitous language, which helps you achieve this domain-driven design approach. Now, what do you mean by a ubiquitous language? To give you an example, suppose I have a ticket reservation system for flights. Now, here, all the terminologies that I used would be related to maybe aeroplanes, flight attendants, customers, and all those things. Now, even if a manager refers to this so-called architecture, he should be able to understand the terminologies that are used here. And also the developer. That means we are bringing every team on the very same page. And a language that does that for you is called as a ubiquitous language. Now, again, a ubiquitous language would be designed in such a way that it focuses around a particular domain. And the architecture that is developed out of it is called as a domain-driven architecture. What is a ubiquitous language? We just discussed that. So why is there a need of a domain-driven design? Yes, there are quite a few reasons actually. Firstly, we need to understand that here the focus is on a particular domain. So if you take a look at the last point on the left bottom side of the slide, you'd understand that it is mapping to a domain. That means we are mapping our architecture to a particular domain. That means we are focusing on that particular domain. Now this helps you reduce complexity. Why? Because your concern is just that domain. Again, testing the application also becomes easier and maintaining it also becomes easier because everybody is on the very same page. Knowledge rich design. Yes, these applications are very heavy on knowledge that is particular or that is very much focused on a particular domain. It brings business and service together, and it is very context focused, plus it uses ubiquitous language. So how does the architecture of a microservice work? Now, when you talk about microservices architecture, now there is no particular pattern for this kind of an architecture because it can be very complex at times. And if you have a number of microservices, all of those will have different architectures. But you have to understand one thing, the base remains the same. That means no matter how complex or how big, actually the architecture will never become complex, but yes, it might become big because we might think of having n number of microservices, maybe thousands and even lakhs if required, if the application is that big. But let's say that you have an application which is huge in size. No matter how huge it would never get complicated because we are developing small applications here. And each of these small applications will have an architecture that is more or less like this, or at least would be on these pages. So what do we have here basically? We have a client, an identity provider, we have API gateway, static content, CDN, which is nothing but content delivery networks. We have microservices, a management and a service discovery portal or a module rather, and you have your servers and all those things. And basically what happens is if a client wants to use a particular service, the client would send in a request. Now it is the job of an identity provider to verify whether the user is valid or not. Once the identity provider authenticates a user, the request is then forwarded to API gateway. Because a client cannot directly communicate to a service, there has to be an intermediary or some intermediate approach that lets us communicate with the microservices as well. Now, in this case, what happens is we have API gateway. Now, this API gateway, it finds the right service that a client is looking for, and the request is forwarded to that service. The service does it basically communicates with other services and sees how a solution is generated for this so-called client. And once the solution is generated, it is sent back to the client using CDN, that is your content delivery network. Now the static content, basically what happens is whatever content that is generated and is in the form of static, it is basically held by a static content. And the management and the service discovery portals, they have a particular task as well. What they do is, say for example, I have a number of services. Now the management console or the portal places those services on respective nodes. Service discovery, on the other hand, keeps a track of all these services, makes note of services that have failed and all those things. And this record is communicated back to the management portal, and it is the job of this management portal to go ahead and resolve if there is any failure in the corresponding architecture or any of the services. So these components, all of them, they work in tandem, and this is how they bring the architecture together. Apart from that, there are some other concepts which are not there in this architecture. Say, for example, the messaging module basically. So we have an approach where messaging also happens. In case if the client is waiting for a particular reply from a service, in that case, we have a way of communication, and that way of communication is through synchronous message passing. And if the client won't be waiting for a response from the service, in that case, we have a synchronous way of communication. So yes, there are those little components which are not there in this diagram, but they do exist. And as I've already mentioned, based on every architecture, it might be a little different. But this is how the general idea is when you talk about a microservices architecture. So let us move further and take a look at the next question as well. So what are the pros and cons of microservice architecture? Well, we've discussed most of these points already, especially the pros. We've already discussed those. So I'm just going to read them quickly and switch to the cons part and discuss those as well. Freedom to use different technologies, discussed. Each microservice focuses on a single business capability, discussed. Support individual deployable units, discussed. Allows frequent software releases, ensures security of each service, and multiple services are parallelly developed and deployed. Now, what are the cons? It increases troubleshooting challenges and increases delay due to remote calls. Yes, this can be a problem. Why? Because you're talking about n number of microservices, and at times, since they are so independently working, that the whole system as an architecture, when you talk about troubleshooting certain challenges, it can be a problem because we are talking about a complete decentralized governance. But that is something that can be managed, and as I mentioned, we have different portals that take care of all the services, and these services are since monitored in real time. This does not become a huge issue. Now, increased effort for configuration and other operations. Yes, configuring these applications can be a problem, but then we have something called as REST APIs that ensure complete integration of these services. And again, this issue can be taken care of. Difficult to maintain transaction safety. Security can be an issue, and that is a concern that affects almost every software, and you cannot be 100% secure in any possible way, but this approach gives room for security as well. Tough to track data across various service boundaries. Yes, again, individuality may not be always good, so this can be a drawback. And difficult to move code between services, but that is not needed in most of the cases, so that is not a problem here again. So these were some of the cons and the pros which we already discussed. So let us move further and take a look at the next question. What is the difference between monolithic, SOA, and a microservice architecture? Now, when you go back in time, the first architecture that we had was a monolithic architecture. That means you had a single container that had the complete architecture, all your services, all your databases, not all your databases. Basically, you had a single database that corresponded to all these services. And yes, all the interdependencies, those were inside one single container. Now, all the advantages that we discussed about microservices become a disadvantage here, because since you had a single container or a single architecture, deploying was a huge issue. A single failure would mean that you would have to go ahead and work on the application and then deploy the complete architecture. There was no fault isolation, because if something failed, everything depended on it, and then you had to go ahead and repair that part. The other services had to wait for that thing to mend and then go back to working again. So yeah, monolithic architecture had quite a few other problems. Scaling was a problem. As I mentioned, fault isolation was a problem. Then there was no individual development, and deployment was a huge issue. So this architecture, though simple to build, actually it wasn't even simple to build, to be honest, because you're talking about a complete application development. And since you do not have individual applications that are being developed, the whole team had to work in together, and bringing up such huge teams can be a problem. Plus, there is too much dependency on each other. So this also affects the functioning or basically development of a software. So it wasn't even conducive or easy for development in any possible way. So these are some of the disadvantages when you talk about a monolithic or a single unit architecture. Now, when you take a look at the next approach, that is SOA, it is similar to microservices, but here the difference is your monolithic architecture is basically divided into smaller units, but these smaller units will also have some subunits. And that means you do not have complete modularity. You do have modularity, but that is to a smaller extent, not to the best possible extent. When you want complete modularity, you have to go ahead and choose microservices, where if you take a look at monolithic, it is a single architecture. SOA, it will have say 4 features in this case, and each of these features will have individual modules. That is not the case with microservices. You'll have individual modules directly, or the complete modularity that we are looking for. When you talk about features, features are just for the reference sake, and all of these modules would be able to go ahead and refer these features. So that is the difference between SOA and microservices. Now these two are little close to each other, so we can just go ahead and discuss those. But when you talk about monolithic architecture, it is completely different from these two architectures. And there you go, we have the same question, that is, what are the key differences between SOA and microservices? To be honest, there are quite a few differences. That means the approach is very different. When you talk about SOA, they focus on sharing almost everything with other modules. But when you talk about microservices, here the aim is share as less as possible. So the approach is completely different. Apart from that, as I've mentioned, you have modular applications in SOA, but there are still a lot of interdependencies. That is not the case with microservices, basically. The other thing is, when you talk about intercommunication between services in SOA, you need a middleware for communication. But microservices, they're completely independent and you do not need a middleware. They directly communicate through REST APIs. Now, if you take a look at this architecture or this image, what you see here is it is nothing but a shopping application. Now, these are the three common things that you need. You have a user account application, a shopping cart application, and a product catalog application. Now, what happens is inside these applications, you would be having minor services. So what microservices does is it just goes ahead and has three features, that is a shopping cart feature, product catalog feature, and a user account feature. Now, this feature will have nothing but those policies or those functionalities that would be needed by the individual modules that your SOA is hiding. So you have these three features, and apart from that, you have the modules that are independent of all these features, and they can just go ahead and use these features if required. Say, for example, you need something like display product service or update your display service. Now you have various other things like check inventory service, product rating service. Now all these are terms related to your shopping application. But as you can see that this architecture is completely independent and it is more modular compared to what you have in an SOA kind of an architecture. So these are some of the key differences when you talk about SOA and microservices. Let us move further and take a look at the next question as well. What are the challenges with microservice architecture? Now, when you talk about challenges, first thing that should come to your mind is automating the components. Yes, you can go ahead and automate all the components, but maintaining these components is a huge task, and automation is working smoothly is something that needs constant attention. Configuration management and perceptibility basically. Now, when you talk about perceptibility and configuration management, you need to understand that this is nothing but an approach that deals with the complete design that you're talking about. And configuring these many microservices and having clear architecture for it can be a problem at times. Debugging. Now, debugging is another issue here because we have fault isolation, and if some application fails, it does not affect the working of any other application. But that also means that you also have to be continuously monitoring these applications, or individual monitoring is something that has to be done. And that is why when you talk about system failures, dealing with such failures can be a problem in the overall architecture. Even if it does not affect the functioning of other applications, still that application has gone down and it needs to go up. So monitoring becomes a problem here. Plus, troubleshooting so many errors for individual microservices can be a problem at times. So the next question that we have is cohesion. Now, when you talk about microservices architecture, you need to understand it is a designing pattern. Now, when you talk about a designing pattern, 2 points that should come to your head is cohesion and coupling, because a good design will always have high cohesion and low coupling. To understand this, we need to understand these two terms, as in what is cohesion and what is coupling. Cohesion is nothing but the bond between an application or an intra bond within an application. To give you an example, we have a molecule. Inside a molecule, you'll be having atoms. Now, these atoms, how closely are they bonded to each other? This bond is something that is called as cohesion. Now, cohesion should be high when you talk about a microservice. That means we are referring to the fact that the interdependencies inside a container, the database, and the service that is running, how closely or how well gelled up are these with each other. If they are very closely bonded, that is good for the microservice. Now, when you take a look at it from a bigger picture, you're talking about different microservices. The bond between these microservices should be low. I mean, if one fails, it should not affect the other one. If one is being developed, the other one should still work smoothly. That means interbond between two applications on microservices, it should be loose. That is why we are talking about low coupling. And this interbond is nothing but coupling. Intra-bond inside a container, it is cohesion. Interbond between two different applications or two different containers is coupling. That is why when you want a good design, you need high cohesion and low coupling. The next question is, what is REST and RESTful and what are its uses? Now, these are nothing but APIs. That means application protocol interfaces. Now, REST stands for representational state transfer. These are more or less used for integrating with your applications much better. Now, you're talking about a decentralized architecture. And to bring up such an architecture, you need to have a medium through which you can communicate with all these services in a much better way. And your REST or RESTful APIs basically help you do that. What is an actuator in a Spring Boot? Now, this is something that would give you real-time analysis, or rather, it would give you or let you monitor your application when it is in its production state. Now, what it does is it just goes ahead and gives you all the information about a particular application. That means you can go ahead and monitor all of its metrics. That is what an actuator does. It gives you information about an application in its running state. What is Spring Boot? Now, for that, you need to understand what Spring is. Now, when you talk about Spring, the first thing that should come to your mind is it is nothing but an approach towards software development, or not software development, basically web services development. It gives you all the ingredients that are needed as far as a web application is concerned. Think of it as a shop where you get all the ingredients for web development. Now, when you talk about Spring Boot, it is the customized version of your Spring. To give you an analogy, think of this approach or relate it with something called as cooking and eating food. Now, when you have Spring, here you'll have all the ingredients, but you'll have to go ahead and cook your own food and eat it. When you talk about Spring Boot, it is a customized approach. We have ready to eat food, right? So ready to eat food or ready to cook food is something that is your Spring Boot. That means all your ingredients, spices would be mixed. All you have to do is you have to put that food inside the oven, heat it and eat it, as simple as that. So that is what a Spring Boot is. What is a Spring Cloud? Now, when you talk about a Spring Cloud, again, it is something that lets you get real-time analysis and perform finite amount of data processing. It is nothing but an API that is provided to you by Spring, and it helps you get rid of various complexities as far as an architecture is concerned. So what are the problems that are solved by a Spring Cloud? Well, firstly, what it does is it reduces the complexity with distributed systems, or the complexity that is associated with distributed systems. Service discovery becomes very easy, and it also helps in load balancing. It takes care of redundant code and application development and does help in improving performance. So what is the difference between REST and microservices? Now, you need to understand this point that microservice, as I've already mentioned, is an approach towards software development. REST, on the other hand, it uses this approach and helps you develop applications. Plus, microservices, when you talk about these small individual applications, they work very well or function very well. Plus, it becomes very easy to develop microservices when REST is used for developing these microservices. So these two are kind of interdependent, but you need to understand this basic difference. Microservice is an approach. REST is a way of building microservices. What are the different types of tests for microservices? And there are quite a few tests. I mean, if you've ever heard or learned testing to any extent, I believe since you all are here for this session, you might have heard about basic testing, that is manual testing and automation testing, and what those things are, or at least read about it a little. If not, do not worry, I would be talking about these as well. But these are very common terminologies and they're used in almost any kind of testing. So let's go ahead and try to understand them a little more. So when you talk about microservices architecture, it follows the pyramid law. As we move further, we would be discussing this as well. So when you talk about pyramid law, certain tests, they are actually performed at almost every stage, and those are at the highest priority of the pyramid that forms the testing pyramid is what I'm talking about. So certain tests, as I mentioned, they have higher priority, or not higher priority, rather they are implemented a lot more times than the other tests. Those tests are your unit tests basically, and to some extent at times performance testing as well, but to some extent, not completely. Then you have at the second level, you'll be having your exploratory tests, where these tests are also happening or happen frequently, but not as frequently as your unit test. And then you have your acceptance test and performance tests. Now these tests are for the stakeholders. That means when you're presenting or giving your end product. So these are superficial, not superficial, but they actually go ahead and just test the end working of an application. So they happen very less compared to the other two tests. So these are some of the different tests that are used as far as your microservices are concerned. What is coupling? I believe we've already discussed this point, so just let us move further. What is a distributed transaction? Now, you're talking about a number of applications or services. So all of these services will commit changes. So when you commit changes to a particular client request, what happens is you need to make sure that all the applications are on a similar page. So we have something called as, think of it as a managing entity that ensures that there is a commitment for a particular service from all the applications or all the services. And when that commitment arrives, it is then that a transaction is completed. And this kind of a transaction is called as distributed transaction. What is an idempotence law and where is it used exactly? Now, when you talk about an idempotence law, you have to understand one thing. There are certain results where you would want uniformity. That means if there would be a particular application that would execute 10 times, but that should not vary my end result. That means no matter how many times the application executes, the end result should be same each time. So to ensure this, we have something called as an idempotence law, or that is what it does basically. It ensures that uniformity. What is a bounded context? Now, when you talk about bounded context, you need to understand this point. We are talking about microservices and modularity. To give you an example on the organizational level, we have different teams working on different things. Like your marketing team focuses on marketing your product. Sales team has the job of selling your product. You have a development team that develops your product, a maintenance team that maintains your product. So you'll be having different teams. They would be having different concerns and different interdependencies. So each of this team should exist in a single module. Now, same is with the application development as well. Your each module should have its own independence. Now, this kind of an approach is called as a bounded context or a bounded context. That means your application is bounded within these limits, and these are the things you use, and this is how you go ahead and proceed with the application or towards your functionality rather. What is a two-factor authentication? Well, you're talking about most of the transactions that we do these days. Yes, we use two-factor authentication, but we do not realize that we are using that. To give you an example, I use a Motorola phone and it has a finger scanner. But at times when I use or restart my phone or reboot my phone and I use the finger scanner to unlock my phone, it says enter in the password. That means I've given in a fingerprint as well, but it still needs a second level authentication just to verify that I'm the very same person. So next time I enter in the 4-digit password which I've set and it unlocks. This is in a little reverse order. Normally what we do is we enter in the credentials and then we do all these biometrics. But this is an example of two-factor authentication. Another example would be your ATM transactions. When you give in your credit card details, you're actually putting in your credentials, that is your card number, your name, and your CVV. But when you do enter those details, you are expected to also enter the OTP. That means what your card does is it re-verifies that the details that you've given are correct and you are the owner of this card and also the number which you've entered and it is registered with your service. So this is where the second step of the authentication happens. So this kind of an authentication is called as a two-factor authentication. What are client certificates? Now think of it as gateways or passes. If you have to go for a movie, you would be buying passes, or if you have to go ahead and attend certain concert. Let me give you another example, a better example. Say for example, you visit a certain restaurant or maybe some club. Now there what you do is you pay in your cover charges, right? So you are given a band or something which says that for tonight you can go ahead and you can use their services. So once you have that band on your wrist or whatever, a card or something, when you go in, you have certain freedom to go ahead and use maybe their dance floor or consume their whatever it is, cocktails or food and all those things. So this is what a client certificate is like. When you have a particular application, when you have a client certificate, you have a digital certificate that tells you that you can go ahead and use a particular client system or you're authenticated to go ahead and use following services basically. What are the types of credentials of a two-factor authentication? Now we just discussed it with few examples. Let us just walk through these points quickly. Now, what are the credentials that would be needed? Something that you know, or in simple words, it is nothing but your credentials, your card details or your CVV number and all those things. something you have. Here, again, a part of your credentials that you have and which you can enter. And finally, you have your something you are. This is where they're referring to the fact that if you're using some biometrics, in the example which I gave you where I used my finger basically for the scanning purpose, that is what they mean. Maybe your retina scan or all those things. So something you know is your credentials, your password and all those things. Something you have is your OTP or the value that is generated back to you. And something you are is nothing but your bodily scannings and all those things which you use for unlocking. So these are the credentials you might require when you talk about a two-factor authentication. Okay, so the next question is, what is the use of PACT in microservices architecture? Now, you can think of it as a testing approach. What it does is it lets you test your contracts basically. Now, not contracts. Since you have a provider in microservices and a client that is using these services, now both these teams or these people, they come on terms or an agreement. Now, when you talk about these agreements, you're talking about communication between these two. And these communications are governed or rather tested by something called as a PACT. Now, it is nothing but a testing approach and it is used for testing these communications which I just discussed. What is an OAuth? Now, when you talk about OAuth, you're talking about Open Authorization Protocol. Here, you can actually go ahead and use the provider's services. And to do that, you would have to go ahead and use some third-party tools which would let you access those services. What is Conway's Law? Now, this is something that helps you maintain the integrity of an organization. Now, when you talk about an organization, they would be having applications or a particular structure for the applications that are built. Now, if a new system or a new application is to be built, it has to be on the similar lines or the guidelines that the organization has defined. To give you an example, Coca-Cola makes cold drink cans. Now, when you talk about these cold drink cans, they have fixed dimensions and those have been decided by the company's organization. Now, if they're launching a particular product, they might not make the exact same can, but what they would do is they would be having certain principles that need to be followed that keeps the other product or the newer product also on the similar lines. Now, this is what Conway's Law preserves. Each time you have a new system, it has to be constrained or it is constrained with the properties the organization follows. So this is what Conway's Law is. As you can see in this image, organization has a particular definition. As far as your software development is concerned, as you can see, the organization has a particular approach. What Conway's Law does is it lets you have a system that follows a similar approach. And that is what is reflected in the system that is being developed as well. So the next question is, what is contract testing? Now, contract testing is nothing but a superficial testing. Superficial again would be a wrong word, but it is a test that does not go deeper or test the complete application. Now, what do I mean by this? These are more or less the behavioral tests, and these are done just to ensure that the system is working fine or the expected output as far as a system is concerned is up to the mark. To give you another example, we all appear for examinations. Suppose you need to prepare for a particular examination and you maybe prepare for it for say 3 months duration, and then comes in your exam time and you revise it for 2 days and then you go for the exam. And on the day of exam, what you do is you just overlook or walk through the concepts quickly. Now, this kind of an approach, when you bring it into testing, it is called as contract testing. What is end-to-end microservices testing? Now, this is completely opposite from what we just discussed. To give you an example, think of it as your bike servicing basically. When you give your bike for servicing, there are certain issues that do not occur every time you give your bike for servicing. Say, for example, your brake failed completely and your brake wire needed replacement. Now, this is something that won't happen every month, but this was an issue this time. But there are certain things that happen every month, like your oil checking, your bike washing, tightening certain screws and all those things. So this kind of an approach that happens every now and then has to be done frequently or has to be done end-to-end. This kind of testing is called as end-to-end testing. Now, when you talk about microservices, you'd be having quite a few loose ends because you're talking about n number of services. Bringing them together and fixing in the loopholes can be a problem. And end-to-end testing fixes those loopholes. Well, this is something that is little out of context. To explain this, I'll have to go into something else. So I would rather skip this question and move to the next one. What is the use of a container in microservices? Now, this gives you modularity. You have your code libraries in a single container, your microservices, and also the database. Now this means your application, it works independently. So this is what a container does. It gives you that modularity. What is dry in microservices architecture? Since you're talking about too many applications and too many microservices, there might be a possibility of code redundancy. Now, what happens when the code redundancy occurs? Well, basically, what it does is there might be a piece of code which everybody is writing. Instead, what you do is if you have a particular set of code, once you write it, you kind of patent it. Patent won't be a right word, but you would create a library out of it. And once you have that library, it can be used by others as well. Now that is what DRY stands for. Don't repeat yourself. This ensures code reusability. A code that has been created by someone, and if it can be used by others, let them use it. A consumer-driven contract. Now this kind of a contract is used to keep people on similar pages. That means your provider is allowed to set certain set of rules when he is deploying a particular application. And the consumer who wants to consume that application, when they have this contract, they basically try to be on the similar page. That means client has a particular set of requests, and when the client mentions those requests to the developer or the provider, he should adhere by those requests. So this kind of a contract is called as consumer driven contract, where consumer is made a priority and accordingly a software is deployed. Basically, what is the role of web RESTful APIs in microservices? Again, REST plays a very important role. I believe we've already discussed this point. Microservices, you're talking about independent development, and for that, REST is a very good approach of web services which can be used, and it also provides you with various APIs that help you in various other things. We discussed something like monitoring or getting real-time analysis and all those things. We discussed Spring Cloud and all those things, right? So what RESTful does is it gives you something on the similar lines. It gives you APIs that suit the need of your microservices, and accordingly you can go ahead and have your microservices up and running. What is semantic monitoring in microservices architecture? Now when you talk about semantic monitoring, you're referring to the fact that, okay, let me give you an example again. You have your application which is up and running, but you still do not know whether it gives you the best output or every module that is there in your application is working in the best possible way. So what you do is you go ahead and generate a pseudo transaction. Now this transaction, it runs through every module and generates an output. And when you assure or verify this output and find that all the readings are as you expect it to be, then you actually go ahead and deploy that software. Now this sort of monitoring or testing is called as semantic monitoring. How can we do cross-functional testing? Now when you talk about cross-functional testing, you need to understand what it is first. Well, it is nothing but an approach where, let me give you the scenario again. First of all, you have a client who gives you certain requirements, and then he enters in output and tries or expects an output from your application that you built for him. But there are certain parameters which the client might not think of, or he might enter, and you expect output for those inputs as well. Now, while building an application, you might not consider every possible facet, as in what kind of an input the user is going to give in. So it is the responsibility of the builder or the provider rather to ask for these requirements. And then accordingly, a test is taken care of to test your application for these kind of inputs as well. Now, this kind of a test is called as your cross-functional test. How do you eradicate non-determinism in tests? Now, basically, these are different approaches. First thing you need to understand is what are non-deterministic tests. Now, when you talk about non-determinism, you're talking about a series of inputs for which you may not know what the exact output is. Now, in this case, what happens is when you're generating a particular output, the output might vary each time you enter in a particular input. And there are certain outputs only that are correct, not all of those. So what do you do in these situations? Because this is a very non-deterministic situation where you do not know what is happening with you. So in that case, what you do is you take in various approaches. One of those approaches is quarantine. Now what happens here is, suppose you have maybe say 100 outputs or results, out of which there are 20 which are not correct. So what you do, you put the 80 in one cluster and 20 in the other cluster, and then you test them differently. Asynchronous approach. You might come across tests where asynchronous messaging is used. Now in this case, the output that is generated may be different because asynchronous messaging is something that is little different. Here the user does not wait for your reply. and the output that is generated might be little different. So again, what you do is you use pseudo applications or pseudo inputs for your so-called asynchronous requests, and those are dealt with differently. Remote services and isolation. Again, here too you use something called as stub, or those are predefined inputs or predefined modules that can be used. As we move further, we'll be discussing that as well. So you'd have a clear understanding of these terms as well. So, yep, remote services and isolation, again, they can be dealt with determinism or non-determinism rather, but how do you deal with it? You use something called as your stubs. So as we move further, let's discuss stubs, and you can relate to these terms as well. Time. Now, time can be a constraint because you're talking about applications that run for different times. But yes, a pseudo time again is generated for certain applications, and the non-determinism is something that can be taken care of. So what is the difference between mock or a stub for microservices test? As I've just mentioned, we have something called as a stub. Now what happens in a stub basically? Well, you need to understand this thing. A stub is nothing but a dummy object. Now this is used for testing purposes. It would have a preset or a predefined set of behavior, and that individual or particular behavior is something that it would implement each time it is used. Now in cases where you do not want to go away from normal behavior, you have this predefined stub that can be used. Mock is similar to it, but it has a set of predefined rules. This is where it is different. It has a set of predefined rules that are set initially. It goes ahead and it functions accordingly. Okay, so the next question is, what is Mike Cohan's test pyramid in microservices? Now, when you talk about the pyramid, there are 3 levels in this pyramid. So first level will have unit tests. Now these are tests that happen for individual units. You have service tests. Now these tests, they test the complete service that is there. And then you have your end-to-end tests, which are for the complete development or architecture. Now, as per the law, the tests in the first layer, that is for unit tests, they are the maximum. Service tests are lesser than what unit tests are, but more than what end-to-end tests are. And finally, we have the end-to-end test. Now here, these are the least compared to the above two. What is the purpose of a Docker? Now, Docker is nothing but a container basically. That means it gives you a containerized approach, and it also ensures virtualization at the operating system level. Now it has 3 components. You have your Docker client, your daemon or your server basically, and then you have your Docker containers. And these containers would contain your complete microservice or your complete application. You'd have your database there, you'd have your interdependencies, and also the complete functioning of that microservice. So when you need a containerization approach, you can use something like a Docker, which is a very wonderful and a popular technology to have. What is canary releasing? Now you're talking about an application which might be used by lakhs of people or maybe millions of people. In that case, when there is a new version, you cannot just go ahead and launch the complete version for everyone who is around. What you do is you launch it for a certain set of people, and when it works perfectly, then it is launched to the entire segment. And this kind of an approach is called as canary releasing. That means you release a particular software update or version to a specific set of people. That's it. What do you mean by continuous integration? We read something about dry, that is, do not repeat yourself. This is what continuous integration is also about. First, the code that is generated, it is saved in the form of libraries so that others can use it. And there is a continuous integration of your system. That means even if there's an update, it is recorded and it is released so that others can refer it. If there's an improvement, it is updated and it is released. That means throughout the life cycle of your software, there is a continuous integration and updation. What is continuous monitoring? It is similar to continuous integration, but this deals with monitoring. Now, when you talk about continuous monitoring, you're talking about monitoring in every aspect of your application. Almost everything is monitored and taken care of. What is the role of an architect in a microservice architecture? All the activities which we actually discussed, or all the questions which we discussed now, that is something an architect has to plan. It is similar to building a house. Now there you have an architecture or an architect who takes care of the construction part. Here, the architect needs to take care of the software development part. He is responsible for creating the blueprint or the design. He zones out all the components or plans where all the components should reside and how they should work, whether they are mutually cohesive and how loosely coupled are they. He is also responsible for deciding or helping plan what tools to use where. Plus, there's technical governance which he needs to take care of. So these are some of the roles that an architect takes care of. Can we create microservices as state machines? Well, the answer is yes. Definitely you can create state machines or microservices as state machines. Why? Because you're talking about individual applications, you have your individual databases, and since you have a single architecture or a uniquely defined architecture for each microservice and it is smaller in size, you can go ahead and have a state machine for each individual microservice as well. So this brings us to the last question of today's session, that is, what is reactive extensions? Now, when you talk about reactive extensions, these are an approach which lets you collaborate your results. So what they do is they bring in or collect all the results by using multiple services, and then they combine these results or compile these results together to give you a combined effect. And there is a short abbreviation that is used for it, which is called as RX. So yes, this is what a reactive extension is. As far as this session goes, I believe we are done with 50 questions, and this is where we have to rest our session. I hope you all had something nice and new to learn, and I hope to see you all again. Thank you.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!